Still there?
Yo, what up?
How is your how are your endeavors in your pursuit of excess efficient energy?
Not bad. Kind of on the
we got
back
beef.
burner, but never on the back burners. Sort of
We got beef, Levelist.
what I look for. But Albert, I don't know. I'm thinking the same spot really. I really made one. Maybe I don't know.
You're breaking up, Cyrus.
I thought
You?
I was breaking up there.
Oh fuck.
No, Cyrus is
Listen, we
breaking
got
up.
beef. We got beef, Levelist. Me and you, dude.
Yeah, go for it.
You're scared to use a Fresnel lens, but now you're talking about having tanks of hydrogen like just sitting around all over the place. That can't be
Yeah.
safe, dude. That can't be safe.
Do you know what? Okay, let me ask you a question. We have a propane tank. Those big. We have a 1,000 gallon propane tank in the backyard, and it's got 20 bar of hydrogen, pure 99.9% pure hydrogen, and we shoot it with a rifle. What happens?
Huh? Bro, what?
Nothing.
I just
Hang on.
hang on.
Hang on. This is Jeremy. Let Jeremy answer the question.
I mean, I don't know. Could there be a flame or something, a spark? I don't know. There's no way for this hydrogen to it's not flammable.
Need you to answer the question. What does it do? You shoot it with a bullet.
What giant fireball like in the movies when they shoot a gas tank.
No, absolutely nothing happens. It soon as there is no oxygen inside that tank, therefore the hydrogen itself cannot burn, cannot oxidize. The pressure, the hydrogen inside the tank will exit the tank at 45 miles an hour, which is not fast enough for the oxygen on the outside of the atmosphere to catch up for it to oxidize it. So it just fucks off. The hydrogen inside that tank fucks off into atmosphere before the oxygen can make it flammable. So absolutely nothing happens.
There's no way this giant tank of hydrogen can frigging explode. It's super safe.
I'm not saying that there is no fucking possible way. But
how does it explode?
I don't know.
Leak. If you did a slow leak, right, and you allowed the fuel source, like the air, the oxygen, and then create a flame and allow that to catch, you could theoretically burn it off as it's as you know the pressure's coming out, as it kind of fucking goes into the atmosphere. You can kind of keep refueling the flame, but to get it to backdraft inside the tank and blow up, I just don't see that happening.
Yeah, it doesn't happen.
Could this burn your house down? What's the chance?
There's no way to get oxygen to the spark. Like, say you were trying to create a spark with a gun bullet. There's no way to get oxygen to it because
the hydrogen. A random chance, a random arbitrary amount of percentage. What's the percentage this could burn your house down?
Less than 3 zeros and a 1. 0.0001.
What is it?
I don't think there's so many valves on it, and there's pressure release valves. There's all kinds of safety measures.
Bro, I buy it from the welding store. It's actually a real cheap gas, and the guy didn't even know. He thought it was going to cost an arm and a leg. The bottle costs an arm and a leg, and I know that for any gas. But it was like $24 for a refill. He's like, "What?" I was like, "Yeah, right. It's hydrogen. It's actually really cheap to make."
Yeah, Jeremy, the hydrogen itself, because it's so pure, it's 4 nines fine on the hydrogen. It's so much lighter than the nitrogen and oxygen down here on the surface level that it just literally shoots up to the top of the atmosphere. It goes back to where it's at normally.
Mm-hmm. I mean, the only danger is that one day you'll walk to your tank and you'll have no more hydrogen in it. You'll be like, "Damn it, I gotta go to the welding store again. Get another refill because it fucks off." I like to slip.
Actually, full circle. So the reason I asked you the question I asked you about your efficient energy is because, or instead of going to the place and buying hydrogen, you can make yourself a hydrogen generator for fairly fucking simple and fairly cheap.
Fairly cheap, bro. We separate the anode and the cathode.
Well, if they're selling tanks of it for $25, I mean, how many solar panels does it take to make that tank? Levelist.
Well, like I said,
$25 tank. How big is your $25 tank, and how many solar panels or what drinking birds or whatever you got do I need to make that tank?
Why are you making hydrogen? Like, wait, hold on.
Exactly.
So, I disconnected.
Energy storage.
I would
It's the
argue.
battery.
Yeah, I would argue that
Okay.
hydrogen is a better means for storing energy than batteries itself. If we make a hydrogen generator while the sun is out, we use solar panels to produce the hydrogen, and then we store it inside those tanks. We can come back 10 years, 20 years, 30 years from now, and then we can use a fuel cell, hydrogen fuel cell, to turn that hydrogen gas back into electricity on demand whenever we want it. If we were to do the same thing with those batteries would be
Dead.
Not gonna
You got
fucking
nothing.
dead. So
Nothing.
now I'm not saying that I'm anti-battery. What I am saying is that
saying he's anti-battery.
no, I'm not, but what I am
I'm
saying is that
anti-battery.
we don't
Again, I hate batteries.
we don't need the size batteries that these. Have you ever seen these like full expensive off-grid batteries, battery
Giant
banks? I mean, we're talking like
banks, yeah.
30,000 kilovolt batteries, you know, like
Takes a spare room.
Yeah.
$25,000 worth of batteries. What I'm saying is that so instead of spending all your money on batteries, you spend your money on a fuck ton of solar panels, so that during the day when the sun is out, all the work that you need to be done can be done directly from those solar panels. So you don't need to be storing up your batteries, because you're going to be washing all your clothes during the day. You're going to be running your air conditioner when it's hot during the day. You're going to be pumping all your water, your washing machine. Everything that you need a high electrical load from, you just pull directly from your DC. Everything that you're not using from those solar panels, from your needs, you send that power to your hydrogen generator. That hydrogen generator then stores all that hydrogen inside your tanks. You have a prolonged...
How many tanks you need to run a house, bro? How much compared to the batteries? Like, how many thousands of dollars in batteries, and then how many thousands of dollars in tanks for that to run a whole house?
So I'm just gonna go by the video that I showed this guy. This is the guy that he runs he's been running his entire operation.
That I didn't watch?
Yes, yeah, of course.
Okay.
So that guy's been running his entire house on nothing but hydrogen for 16 years now. He had now. This is excessive. I don't think you need to go this big, but he had those everybody's seen those big off-grid 1,000-gallon propane tanks, right? So those only store like 10 bar or 20 bar. So it's only like 150 psi. You can the welding tanks that Syrus is talking about, you can go up to like 4,500 pounds per square inch of hydrogen inside those tanks, right? So he has a very very low tech. Those tanks are cheap as fuck. You can buy used 1,000-gallon propane tanks for like $700. Now he says, I'm just going by his words. He said he had 12 of them in his backyard. I think it said it took him like a month and a half or 2 months worth of sun for him to completely fill those 12 tanks up with his hydrogen generator. And the amount of hydrogen in those tanks was 148 days worth of electricity for him.
It took him how long to fill it up?
I think it said it took him about 2 months.
And it lasted for 148 days. Was that two good months or 2 bad months or average months? Like,
he did it in the middle, two excellent months, right in the middle of summer. He just decides to run all of his hydrogen needs in the middle when it's easiest. He just runs that hydrogen generator like 8, 10, 12 hours a day.
Two of the best
fills his
months.
tanks up. Yep. And then he has 6 months worth of his worst months for electricity needs. That's what I'm saying. It's just a better battery.
I have to look into that. Yeah, way better. Yeah, compressed gas is way better. Way better.
And then so I would do, instead of getting those big old 1,000-gallon tanks, I would just do what Syrus is talking about. And what you do is you get big boy welding tanks, and then on top of that, to make things even more inert and more safe, is that you can put a hydride, a metal hydride, inside of those tanks, and it will allow them to store like 400% more hydrogen than if the hydride wasn't inside there. And on top of that, it allows you to store that, or to pull that hydrogen back out of that tank at room temperature. So I don't know if you're familiar with metal hydride storage of hydrogen has been around for a long time, but the traditional, like you can put like shavings of titanium and iron and aluminum. They put this like micro nano metal inside those tanks, and the bonds in between all those small metals allows that hydrogen to pack itself even tighter inside the tank, so you can pack more hydrogen in there. But the problem was to get that hydrogen to come back out of that metal that's inside the tank, you had to heat the tank itself up to get it to be like a buoyant or whatever enough to come back out and pressurize to come out of that tank. And so what they've done now is they have these other materials where you can just have it sitting at room temperature, and you only got to heat it up to like 80 degrees, 100 degrees Fahrenheit, and the hydrogen will come out. So it's just completely inert and safe. It's a beautiful technology, man.
How did you collect it? I missed that part. What took 2 months, and how did you collect it?
2 months for 168 days, you said?
Yeah. It's
crazy.
he had a huge solar panel array. He had like 60 or 70 solar panels. And he's running all of that electricity into a hydrogen generator. And the hydrogen generator is producing hydrogen, and he is pumping that out, purifying it and drying it out, and then he's pumping out into these old school propane tanks.
Gotcha. Okay.
I mean, that's $700 a piece, dude. Go to the welding store, buy a brand new tank for $350. Depends how big of a tank, but like if you get $450 tank, you're not going to be disappointed. Like you're not.
You saying
they can hold a lot of pressure.
You could do it cheaper than what Levelist does it?
Well, if that propane tank is $700, then absolutely not. I'm not going. I'm just going to go to the welding store and get a hydrogen tank, the biggest one.
No,
it's like
you make a rack.
$450.
No, you make a rack. You get like those big boy welding tanks. I forget what are they, like 500 liters, 700 liters, something like that. Is that what's inside?
Oh man, bro, it gets so funky in the nomenclature.
Yeah,
I was learning they don't use gallons or it's just so fucking odd. The names.
What's even worse, I was learning about it from a British guy, so he was giving me all these metric numbers, and I'm trying to look it up over here for us, and I was all fucked up. Like, so I don't even know what those. Yeah, exactly. But anyway, he had like a. He made like a pallet. He got like a Harbor Freight trailer, and he made like a dolly, and he laid all those down, and he had like 7 or 8 tanks inside of like this Harbor Freight. And he's like, you know what you do is you make those tanks, and then you could sell them to all these corporations, these companies around you. Everybody uses hydrogen all the time. They use it for like cleaning or something like that. I forget what he said. And then instead of using batteries for electricity, you just use the hydrogen in a fuel cell. And the fuel cell's pretty fucking simple to make as well, dude.
Wait, how many cubic feet do you need of gas?
A lot.
Dude, how much for batteries compared to the hydrogen tanks, dude?
About. So I'm trying to like get like a price on it.
How many gallons? Well, you can do the math. How many gallons and how many psi? Figure out how many cubic feet or how many kilograms he's got in there of hydrogen. Whichever one you want.
Levelist, what's the batteries cost to the tanks, to this whole setup? Because you got to have a whole setup for this.
That is the problem, is like batteries are fucking dirt cheap, bro. I found some batteries. Let me show you what I found, dude.
So you say the batteries would be cheaper, but this is better because why?
It's just longer term. Like those batteries are still going to last 20 years, but you need a bunch of electricity and computers and monitors. You need a battery management system where like the hydrogen is just dummy proof. You just fucking send it into the tank, and then you don't have to fucking worry about it. Doesn't matter if it gets hot outside. Doesn't matter if it gets cold outside. Doesn't matter if you leave your property, as long as fucking, nobody's going to try to throw it inside of a fire or something like that. It doesn't matter. It's just like dummy proof. I'm looking for like dummy proof and old school.
You can run compressed air, bro. Old school?
You gotta have what kind of systems you got? You gotta have a system to turn it into hydrogen, and then a system to turn it from hydrogen into electricity, and then some kind of thing where you have a charge controller.
Fuel cell.
All these questions, Jeremy. If only someone had sent you a video that might explain some of those fucking questions.
Got them.
Okay, are they in there?
Jesus Christ!
I actually have to watch the video. All right.
I mean, you can do compressed air, bro. Like old Dutch windmill trick,
That's that's definitely not a bad
same shit.
Either. Yep.
Essentially, except that you just you You store it in compressed air. You always have pressurized air, and you run everything on air.
Have you seen that Amish one?
Turbine or something.
Yeah, that's what the Amish do. They
I
have
think
like
I have. Yeah.
the old school windmill,
Enormous.
and it direct
Yes,
connects.
sir.
There's no electricity. They had an old school compressor from like the 1920s. Yep. They put the compressor on the top of that windmill. The blades turned the actual vein on the compressor. It went down to a pipe, and the pipe itself was connected to like the same thing. It was connected to like 8 1,000-gallon propane tanks, but air tank styles, and they ran their entire fucking business off of nothing but pneumatic air. It was beautiful. Yep. I saw that. I was so amazed.
So we can do the same with the solar too. We can just go straight from panel to compressor to gas tanks.
Well, that's the other thing. I was attempting to explain that to Jeremy as well. That's what I'm into is direct DC instead of. I don't understand why we use AC. Like those old DC motors are so beautiful. Like they don't need constant current like the AC does. Like a real AC motor. If the sun goes behind, or if the sun goes behind a cloud on your panel, and you're powering an AC motor, that motor will eventually fuck up and blow out because you're not giving it constant current. Whereas a DC motor doesn't give a fuck. It will still produce power. You can hook up your water pump directly to the DC panel, and it will run whether the sun is behind a cloud or not. It will just pump the water slower, and when the cloud goes by, and not hurt the motor, by the way. And then when the cloud goes by, it will go back to pumping full power again. It's called like microgrids. Instead of getting your power from the main power company, you set up everywhere where you have like a big motor, a big need for power, you set up its own solar panel directly to that motor. So for example, your air conditioning, your mini split air conditioning, you just give that mini split its own 500 or 1,000 panels worth of solar, and it's not hooked up to anything else. So that as soon as the sun actually hits those panels, that AC will come on and not cost you a penny for the rest of your life. It runs by itself. And you do the same thing for your refrigerator. You can get a refrigerator that runs on a DC motor only. You can do the same thing for your washing machine. You can do the same thing for, you have like 5 big loads. Your water heater, you can do the same exact thing for your water heater. And then you're not actually using a ton of electricity during the day when the sun's out because those grids are all taken care of micro. They have their own special grids. So then all that power, you can just divert all that power for your main solar array to making your hydrogen for you, or, filling up your battery bank storage. That's how I would do it. I would do a mixture of huge solar panel, huge hydrogen tank, and a decent sized battery bank. That's all you really need. Yeah. In my humble opinion.
You may want to place.
I love hydrogen, man.
You may want to place
the fuel of the future. Go ahead, bro. Sorry.
I'm just saying you might want to place a soft start on that compressor. That way the start load amps don't damage your inverter and
absolutely, yeah. It's an excellent idea. Yeah. Well, you can. I have this. So I was learning how to make your own solar water heater. You get a big old sheet of aluminum, and then you coil the copper around it, and then you get a 50-watt solar panel, and that panel will directly power a variable DC water pump. It can input anywhere from like 10 volts all the way up to 50 volts or something. I forget it now, but it's variable. So it doesn't matter if it goes behind a shadow or not, it will still provide power directly without needing to be hooked up to anything else. It's like a mechanical, mechanical water pump.
You can get hot water mad easy with
I know, we should all have
by putting a box. If you put a box in the sun and then coil, you have plexiglass in the front and you coil a whole black hose in it. That if the sun just hits that, I don't know what your solar panel is for, the pump.
I put those batteries. Look at those batteries. That's a 48 volt, 100 amp hour. So that's 5 kilowatts worth of power right there for $600 fucking dollars. That's fucking amazing, dude.
For the battery. So why, dude, that's got to be the simplest, easiest thing.
Like my problem right now
with hydrogen, you got to have a thing to fill. There's got to be what's the system that takes from the solar panels, makes hydrogen, and fills the tank. That's got to be a whole thing. Like, this is a whole elaborate setup.
Yeah, and a pump. And
It's not going to be cheap once you start like filling your cylinders. That process to fill the cylinders, that's going to be a little tricky. But I mean, once you get it, it's, you know, from there on
none
out,
of this is
you're
cheap.
banking.
No, you're right. None of it's cheap, but once it's actually paid for, there's no
cheap.
reason why generations of people would not be able to enjoy its benefits.
Well, yeah, that's how I'm
Yeah.
looking at it. I'm looking at it as
you get rust.
yeah,
You
but
get
I'm looking
rust
at
and shit.
not. It doesn't really rust on the inside, man. As long as you keep a coat of paint, you're golden. You just maintain your tanks; you'll never have problems. Unless you fuck up your electrical and you end up with some type of electrolysis going on, you're good. But I'm looking at it as like what he's talking about. If you set this up for the home, then
A
and you
compound.
pass down the home to like next generation, and keep it in the family. Like there's some serious potential to save money.
Aha. Aha.
See, the problem with DC, man, so right now, I need 483 phase. And the problem's in the 480. Right? I have a machine, need to power, off grid, and it's 3-phase 480. So everything that I've been looking up and looking towards is geared up towards industrial AC. I'm not fucking. I'm going Nikola Tesla. I can't, because DC is cool, but like you said, everything has to be dedicated, sort of, because you're limited by the run. You can't run long wires from corner to corner unless like you're pumping 500 volts DC, which you should from your panels.
Microgrid.
You have
microgrid.
well, but that high voltage DC, then you run into the old school chip issues.
Do you see the system I just showed you the picture of? That's a six bank. It's a 6 banks, 48 volts in each bank. We had 30 solar panels, 32 40s, and we had 10
How many kilowatts?
270s.
Kilowatt hours. How many kilowatt hours in the battery bank?
6,000, 2,000, 6,000 X, the EG4X, the new X's, and we ran 2 mini splits all day long, and I could run 1 mini split at night off the 6 banks, and it would run all night.
How many? Philip, give me specs.
Solar. I mean, I'm sorry. She would do laundry too. She did laundry. She would use the dryer at night, and that's that's 240, or 220, or whatever the hell it is.
So those batteries.
How many kilowatts of panel? What's your kilowatt? How many kilowatts for your panels?
Look in the chat. I put some panels in there.
All right, so each bank is 48 volts. Each bank is made up of 4 100 amp hour iron phosphate batteries. So you got 24 batteries, 6 banks each. 6 banks, 4 12 volt 100 amp hour batteries each. And that ran a whole freaking house with 2 mini splits, the fridge, lights, when I was roasting. Well, the roaster's a propane roaster, but
it's about 15 kilowatts.
It's a lot.
Yeah, I'm looking at the charger. Says 6,000 XP. I'm gonna assume 6,000 watts each, 6 kilowatts.
So look at those batteries. Those are 12-volt batteries, Bear.
Yeah.
So look at those batteries I put
48.
in the chat. Those are 48. So his whole bank right there, all those is basically 3 of the batteries I put in the chat.
Yeah.
And so those batteries I put in the chat, those are 12 cents a watt. And then those solar panels I put in the chat, those are 21 cents a watt. They're giving it away.
Dude, is yours a 400
Sorry,
amp hour
17.
48 volt? Is that a 400 amp hour 48 volt?
No, 100 amp hour. 48 volts at 100 amps. It's 5 kilowatts.
Big, but still, that's not the same as 4 100 amp hour. It's still 100 amp hours, even if you have 4 of them. But it's nice though. Those are expensive there, dude. Like when you look at the price they charge you, unless you're gonna make them yourself, the 100 amp hour ones are always cheaper than buying like the 200s or the like the 370. They have like weird numbers, but you can get them 200. I think again like 350. They got different ones, but they're always more expensive than just buying like, oh, I'm gonna get 4, tie them all together, and make a 48 volt bank. Now, what's nice about yours is if you made a 48 volt bank with 4 of them and made a 400 amp hour, like, you know, like one bank out of 4 of those, that'd be badass. You could use just like 2 banks and then you'd be good. You'd like have more juice than you'd ever need. It's funny, it says 51.2 volts, which is the same thing as instead of 12 volts, it always says 12.8, you know. I think that's what mine said, 12.8.
Yeah, you're running. I wouldn't run at this point. I think, you know, the 12 volt solar systems they've gone the dodo. I believe that it will. The new norm is 48 volt, and I think it'll go to 96 volts. And if it does, like if we all had 96 volt batteries, almost all of the appliances in your house run right there. Like, you know, we're running 110. So if you were just to run straight DC at 96 volts into all of your appliances, it would just run straight off the solar panels. And then whatever your appliances aren't using, it just goes directly into the battery. And then we don't have any losses. There's no conversions. There's no losses. It's more efficient. I don't understand why.
Oh yeah, during the day, if you're just gonna do shit during the day while the sun's up. But you know, usually everybody wants to cook dinner, you know, so that means you're gonna be using your batteries unless you cook really early, you know. Uh, you know, just the mini splits don't use a ton, but you know, things like the dryer or if you know, like turn on the stove, dude, like a stove will just eat your batteries down, you know.
Well, like I said, I learned about it from this guy. I mean, these guys were living like dirt cheap. He only had 1,400 watts worth of power. So he had like these old 200 watt panels. I think he just had like 6 or 8 panels is all he had. So he's running all of that power into his machine shop. And he had these like old school machine. He had a lathe and a drill press and a bandsaw and fuck, what else did he have? He had a bunch. He had a bunch of stuff. He turned them. No, that's exactly what he did. He turned every single one of the machines in the shop on at the same exact time to demonstrate that yes, that DC motors do not need to have constant current, or they are completely safe. They'll just run, but they'll just run at a slower speed. If you're cutting a piece of wood, it'll still cut the wood. It'll just slow down. If you're drilling a piece of metal on your drill press, it'll still drill. It'll just slow down. Whereas, yeah, so it's just a safer, longer lasting. Like, I don't know if you've ever been around those old DC motors from like the 30s and 40s. They were built to last for like 500 years. All you got to do is take them apart, dust them out, clean them out, put them back together, grease them, and they will run another 100 years. They were designed to run 24 hours a day.
Yeah, if you've ever like in auto 2 class, we learned how to like kind of redo a starter, you know, on a car. This machine kind of scrapes. It looks like it's scraping the lines out in between I don't know what you call each little row on the motor, and then I think they would turn it down a little, take a little bit of the surface off, kind of, but and then
The
you
commutator.
brushes in, and then it'd be new, you know, it'd be just like work brand new. What was that
What
word?
the thing about DC is like you don't really have to change your life that much. Like, who the fuck needs to? You know, once the sun goes down, it's not like you're going to start your workday when you're at home or in your shop anyway. So you just learn to get all of your chores done while the sun is out, and then you have absolutely no bills, and you're not in debt to anybody.
True, that's true, and it's very nice, but still, once you know, inverters go up, inverters arc, they have little freaking problems, and if you don't know how to fix those, and you have to send them in, you've got to have a backup one.
Well,
Believe
once
me, I
again,
learned that freaking.
another benefit to direct DC is you don't need inverters.
Bro, you don't want
Yeah,
to
the
know
only
how
thing for
much
the inverter is just
the
switch
three-phase ones are.
AC,
Dude,
DC.
you just talking about going straight from the solar panel to your shit? That's pretty wild. I knew
Yeah,
that,
so like so here's what you do is like you match the voltage of whatever motor you're running, which is usually either 90 or 180, like depending on the size, like 1/3 horsepower DC motors, they'll run at like 90. Once you get into your bigger motors, your 2 and 3 horsepower motors, they're going to want 180 volts at a time. So what you do is you match your solar panels to give it that power. But another key, what you do on top of that, so that you don't get choked down for power when a cloud comes by, is you overcharge the system. You put like twice the amount of solar panels out there, but you
okay.
but wait, I'm not done. So, but
Okay.
after you put those, after you overcook your, after you oversize your panels, all that power that's directly going to that motor, you run it through diodes essentially. Like you reduce, like, it can never go above that amount of power. So you can't cook the motors, but if a cloud does come, then the same amount of power is still able to get and run to that motor. Does that make sense?
Yeah, no, that makes sense. That makes sense. Yep. I mean, the thing is, during the day, like in Arizona, you've got so much power during the day, and I've talked about this to, I don't know, Jeremy, a couple other people, about just like you've got so much excess power during the day usually that if we would have had a well, I would have done the what they call, well, I'm gonna call it the buoyancy and density battery, where you just pump freaking like 10,000 gallons of water up to a freaking higher tank. If you got a hill on your property, you pump it up there to a damn freaking swimming pool up there or some shit, to a tank, and then just open up a thing and do hydro. Just have a hydro generator all night to trickle charge, trickle run your house off because you don't need as much at night. You just need enough to keep things going, just to
So
keep your batteries kind of charged.
I just joined in. I'm sorry to interject here, but what Levelist said was mostly correct. The only problem is that if you're going to, and I have a question for Levelist, meaning, are you an electrician or an engineer? I'm an electrician, almost engineer, but when it comes to certain components in a home, like a motor, there's DC motors and AC motors, so you cannot just wire things like a DC from your solar panels over to a DC motor. It
Why
doesn't
not?
work. It'll fuck it up.
Because the
Why will it fuck it up?
like the mini split has that draw when it comes on. It's like a surge, so you'd have to have what do you call those things? Oh gosh, they keep the surge from happening.
Yeah, surge arrestor.
Oh gosh, there's a name for it. I don't know the name.
It's a surge. That's what it is. A surge protector.
Okay, so it just well, no, it's not like a stupid
Or a
surge
snubber
protector.
diode, or RC snubber.
So when an AC unit first clicks on, it like pulls like a big amount, and this is a thing that keeps that from drawing so much all at once, because that puts a knock on your freaking batteries and on your system all at once. It's like a the same thing when a fridge comes on. It's like,
That's why
I forget what it's called.
capacitors, bro. Capacitors will help you out, dude.
There's
If you
something
put
that
Yeah, but
inline caps on your AC lines, if you have a problem with that, like your inverter shuts down when that happens, well, some caps on the AC line will actually help you out.
Yeah, right. So if you had, let's say you
Sized
had
properly.
your like everything came on at once, your mini split, your fridge, and you had something else. Like that could overwhelm your system and just freaking shut it off if you had like
Once again, that's
not
why I
the same
said
amount. I
that's why I
understand
said
your
microgrid.
idea, though.
Every single motor will get its own dedicated solar panel bank. None of that power will be going anywhere else except to your AC. Your refrigerator will have its own separate. Your water pump will have its own separate. Your heater in your house, your water heater will have its own. I'm talking about microgrids. The solar panels themselves are dirt cheap. I just showed you they're 17 cents a watt. They're giving them away. So instead of having one major solar panels bank and drawing all of your power from that, sending it to your batteries, you just set up microgrids. And then if the sun is out, you get to use that motor for free with no harm to that motor at all, because DC motors do not need to be constant current like AC does. It does not hurt a DC battery to only run 10 watts. It just won't run at all. And there's no downside to that system, only in the sense that you can't use it at nighttime. So you just need to get all of your chores done during the day.
There's an easier way to this, okay? And one of the things that a lot of people are not aware of, and I'm not trying to step on anyone's toes here, but when it comes to a lot of these solar panels, you can build them yourself. And there's plenty of YouTube videos out there that show you how to do it. And the other ones that you might want to just purchase, they come with something called a microinverter. And every single panel has its own microinverter to it, where it converts.
I don't want AC though. I don't want AC. I want DC.
Why?
Because there's less line losses. There's no conversion losses. That's what everything's going to. I don't know if you realize that. Like, everything is just going to have solar panels. Like, have you seen those like those trickle chargers for your car? It's just a solar panel. You set it on your dashboard of your car, and it keeps the battery. There's nothing else needed. It's just dummy proof. It just does. When the sun's out, the system works.
I found that's what I was talking about. The hard start.
I'm aware of what that is.
Starts from happening on like ACs, different things, so they don't overwhelm your system. If you've got like a certain size system, if everything starts all at once, it's some kind of hard start. It keeps that from happening.
The start load amps, I think, is what you're trying to talk about.
Yeah, I forget.
But I'm curious, Andrew. What would be the problem? Have you seen one of these systems at work, Andrew? Because I've literally never talked to anybody that knows this stuff. Like, his channel is very ghosted on YouTube. Like, I've never spoken with anybody. So
I would love to see it. I mean, I watch this kind of stuff every single day, but no, what you're talking about at the moment, I'm not familiar with. But I understand the conceptual theory of AC and DC, and AC has about 57% less voltage drop because of the pulse length of how it's due to the sine waves, where DC decreases.
Yeah, but if the solar panel is 8 feet above where your refrigerator is powering your refrigerator, what do you care about line losses over 8 feet, 10 feet? It will have its own dedicated solar panels.
DC, okay, not at all. I use DC, I use AC, both of them. So when it comes to the conceptual understanding of what is better, well, when I worked at a power plant, yeah, we were generating a whole shitload of voltage, and that is distributed out through the power lines. But if you look up the history of Nikola Tesla and Thomas Edison, then you'll find out that those power stations for DC would have to be installed every couple miles, and the voltage would be extraordinarily high and dangerous, way more dangerous than AC. And that's why we're using AC right now, because of the restricted amount of. I mean, it's still fucking dangerous. Okay, electricity's fucking dangerous. It'll kill people. It has killed people, and then from there is less voltage drop. If you guys want me to go over the calculations on how to do that, I can show you. But
no, Andrew, what I'm proposing is that fuck the power company. I am the power company. What do I need their power for? That's what I'm attempting to distance myself to not need any grid. I am the grid. It doesn't cost but $6,000 or $7,000 to put 20,000 kilowatts of solar panels on my property. That's more than enough power every single day. You know what I'm saying? That's what I'm trying to. Yeah, that's what I'm attempting to do.
Okay, I joined in a little bit late. I wasn't really sure what the premise of this is. I work in this field every single day, so I'm just always interested, and I will interject when it comes to topics like this. Not trying to call you out as being right or wrong or anything like that. I'm just trying to give my own little 2 cents of information because I know a lot about this. And yeah, solar is very worthwhile to install, especially here in California, because our power grid is becoming overwhelmed. And that's why PG&E, which is Pacific Gas and Electrical, that's why they're charging us boatloads of money between 4 p.m. to 9 p.m. Like, oh, that's like the point where it's the hottest in the day or the coldest in the day. It's fucked up. But when it comes to solar, I recommend for people to understand it at a basic comprehensional level, and you can actually use direct current. That's what solar does. Solar, batteries, static electricity, piezoelectric, things like that. And that's direct current, which
like,
is a
for
little
example,
bit of. Please go ahead.
Look what I just put in the chat. Look at those last two appliances I put in the chat. So I don't know if you can, but it's a EG4. It's a 12K hybrid solar mini split, and it runs on its own panels. So you just put like 1200 watts, so like 4 modern panels, and sun comes out, boom, free air conditioning all day long when the sun's out. Above that, 2 or 3 is an over-engineered chest refrigerator with like 5 or 6 inches worth of insulation on there, and it has a DC powered pump. Same exact thing. It only needs it's been a minute. I want to say like for refrigerator mode, it only needs 150 watts to run, to be like 40 degrees.
So the mini split that we had was 12,000 BTUs, maybe.
Yeah, that's 1 ton.
I would watch the my shunt to see how much we would use. So at night with the fridge and the friggin' AC, the mini split running, when it ran, it would use all together. We'd use about 900 watts.
Well, hold on a second. What do you mean you were watching the shunt?
The shunt. I had a shunt that would tell me how much power was going. It was a Bluetooth shunt.
Voltage drop across the shunt.
Victron shunt that would it would tell me how much power was being used.
Yeah, I think the terminology might be a little bit off, because what a shunt is an intentional short circuit, the same way that photocells work for streetlights. And
they called it a shunt, man. It was called the Victrola shunt.
Well, okay, it might be wired in parallel.
Andrew, he's talking about the measuring how many amps are flowing through a system by taking the voltage reading across a shunt. That's it.
Oh, that's a current transformer.
Like the high amperage. Yeah, it's a current reading device. It'll tell you, like, for high amps, if you're using something like runs at 200 amps or something, you just measure the voltage drop.
Okay. I'm not trying to be semantical. I'm just saying that sometimes I need clarification about what people are actually trying to say. Yeah, a shunt is an intentional short circuit which will trip a relay and will shut off a circuit on purpose. It's like one of the only times you'll ever have an intentional short circuit. But it does that to shut off the streetlights.
So if you look at the bottom,
there's a professional.
The list I just shared the picture. I'm sorry, let me finish real quick. At the bottom of the list, that's the shunt we had out of all the Victron's stuff. If you look at that picture, the bottom one.
It's a shunt current measuring device. I don't know what the terminology for it is.
Look at that.
It's mechanical.
It reads how much is going out, or at least that's what it told me. It told me like if the batteries were, what the voltage of the batteries were at, and then it showed what we were using, and then it gave like how many hours they thought it would last, you know, in days and hours, and then it gave you a percentage of the system that was you had used.
All right, a shunt, you know, it can actually, you can wire an electronic device to it, and that would have to be wired in a series parallel with the shunt, and then that would go over to a display device like an LCD display, and then from there, yeah, that it could tell you, and then you can also wire that in parallel for a Bluetooth device like a radio transmitter, and then yeah, that would work. I could show you how to do that as well. I've never done it, but it's not trying to toot my own horn, but I know how to do this stuff. And from there, the solar panels. Going back to the original point that I just came into randomly. If people are going to be using solar panels, then you have to understand how they're going to be installed and what the efficiency rating of them actually are, as well as what
They're real
is
easy.
They're all
I
20%
know
now.
it's easy. Yeah. So when you have to start backwards. Like, oh, what are you trying to use those for? Like, oh, for a motor. Okay. And then a garbage disposal, an air conditioner, a refrigerator. You have to work your way backwards in order to do the load calculations to find out how many solar panels you need, how much of a battery bank you need, and the inverter size, unless you have micro inverters, and also charge controllers if you're using a battery bank, things like that. So, all right, I got to go back on mute. Sorry, guys. I love this subject of conversation because it's something I know quite a bit about. And if anyone has anything to teach me about it, I am open ears.
All right, I probably will hit you up on that when I start building my system. So
cool beans.
But so yeah, I put in this D5 solar hot water pump. So this only needs one 50-watt panel, and when the sun comes out, this motor will automatically turn on with power supplied from that panel, and its range is from 6 volts all the way to 24 volts, meaning it will do its job in any of those ranges, so behind the cloud or not. And then it will passively run water through the solar collector, right? You have a black panel with copper inside there and glass in front of it, and it will just run that hot water inside of your house, into your main hot water heater tank, and then it just does it automatically. It's just, I just want dead simple shit. Doesn't break down. Don't need a bunch of computers. Don't need batteries. Don't need electrical system. Just hook it up to a solar panel.
Yeah, that's cool. You still need to do stuff at night there, bro. And that's when you'll be like, damn it, I don't want to start a generator, you know? You're gonna want at least a couple batteries just you know, to run
So
your
how?
computer or something. It won't
So
take
your size battery bank it would be that's I can basically get your size battery bank for less than $2,000 now. So
yeah,
that's about the size I was looking for, about 15
they were
kilowatt.
they were 160 a piece, and I'm sure if I would have really looked around, it's just that Amazon delivered right to the back porch off grid, so I ordered them through Amazon, and they were running this thing where I think they were like 180, and you could get this coupon that made them like close to 165, I think.
I mean, they were dropping weekly, but before Trump put the tariffs on, like all the solar stuff was just like falling off a cliff. I mean, if we go back to, I forget what the number was, but like, in the 80s when solar panels first started getting popular and mainstream, those guys were paying $10 a watt. And those panels that I just put in there are 17 cents a watt.
Dude, I don't know what brand are yours? Do you know what that would be?
Well, they all come out of the same Chinese factory, but sure, let me.
Maybe. I'm not. I don't know enough about who manufactures them, but I know damn well them iron phosphate batteries. You can tell they're all made from the same freaking place, and somebody just puts like, hey, make mine with blue tops, and this guy's like, make mine with orange tops, and you're like, just put this label on there,
Those panels are called Rec Twin Peak Palette, 350 watt panels. This is just, by the way, like whenever a smoking deal happens on solar, you have to just jump on it, because as soon as people find out about it, they just sell out. So I put like 3 or 4 different smoking deals on panels in here, and like literally within the week, not because of me, but I found it, so it means everybody else found it as well. But they just sell out. Like I found 500 watt bifacial panels for under $100 a piece.
What's a bifacial?
You set it up off the ground, yeah. So it will, it will gain. It will gain. They say 20%. In reality, it's like only 5 or 6%. But it will reflect back to the underside. Basically, the underside of the panel is unfinished, so that it can gain or boost itself up another 20%.
It'd be cool if I had my thing set up perfect. I'd have it just so it kind of like just slowly moved. It wouldn't be that hard to just track the sun. Just kind of they just slowly turn with the day or whatever way. I don't know, but the thing is keeping them clean is about the only thing that you got to worry about. And
hail is what I would be concerned about.
Jeez, I didn't think about that. Well, they need to start making something that's I don't know. Gosh, that would, I don't know. Don't they have some shuttle technology to keep freaking meters from? They got some shuttle technology for our solar.
Modern solar panels that are basically commercially available, you can actually walk on them, and
bend them.
So hail, yeah, it's probably a consideration to take into play. But either way, a lot of solar panels, they have this really specialized type of outer finish, like the glass or plastic or whatever the fuck they're made of, and it's very similar to like how cell phone screens are. And yeah, they're super strong.
What about
Hey, Andy, did I have that correct when I said if I just wanted to overpower my system, my microgrid, so I'm only trying to send one solar panel bank to a, let's say a 180 volt, 2 or 3 horsepower DC motor, and I wanted to make sure it still had full power even behind clouds. So then it's an arrestor. I would apply like a 180 volt arrestor to that, or like, do I have that right? Or amp, it would be amp. So yeah, it just never goes over. But if the sun, when the full sun's out, it will never go above that and not cook my motor. But if the power does drop because of the clouds, it will still get the same amount of power, basically. Because even in clouds, yeah, go ahead.
You're in the right ballpark. But in order to not overcharge the system, you have to have something called a charge controller, which is the same exact thing that is used with solar panels and charging up solar batteries, a battery bank. And the same thing, like if you plug in your cell phone as an example, and all of a sudden it gets to 99%, all of a sudden 100% of charge, then does it continue to go up above 100%? No, it doesn't. It's because there's a charge control circumstance that happens in your cell phone. It's already built in, and a lot of other things as well, where it will shut off because it has a sensor inside of it, which is called a it's a gate. I'm forgetting what it's called.
Well, let's say this, Andy. Let's say, for example, I had a big pond on my property, and I was interested in keeping my fish alive. And instead of running my grid power to run a bubbler out there, I just instead threw a couple solar panels out there to a DC compressor, and while the sun is out, it does nothing but all day long safely and effectively and affordably bubble and aerate my pond for me. And at nighttime, those fish still have enough residual air in that water to not die at nighttime. And when the sun comes up tomorrow, it completely runs itself again without me having to touch anything. That's the type of systems I'm talking about. So maybe I'm wrong. I totally could be wrong, but I don't think I need battery banks and charge controllers for those types of systems. That's what I'm attempting to create.
But this is the downside to that. This is what I'm thinking. Like, you're not ever going to be using everything at the same time. So let's say you got your bandsaw, you got 2 solar panels for that. You've got a drill press, you got 2 solar panels for that, or whatever. One for every little thing you have, and you got like who I don't. Nobody really uses microwaves anymore. But let's say you got a microwave, you got a couple solar panels for that. You got your stove, you got a couple solar panels. So, dude, you got all these extra solar panels for each thing already set up for a dedicated thing. When, dude, you're never going to be using all that shit at the same time. You
Or
could
the
have a
move was
much
just the guy
smaller
that
system and only use everything, like a couple things at a time. You probably end up spending way less money.
All right, the move was the guy that spent 2 months and got 148 days worth of electricity. Now how many peak months he gets like that and shit, but I mean that's crazy if you can get that going on. But my question is, what is in between? That's what I'm saying. Like you need a solar panel. Is that what it is, Levelist? You need a solar panel for the washing machine, a solar panel for the fridge.
Yeah. Yeah, you need electricity. It's just
What's
that
up?
why
wouldn't you want the
absolutely.
solar panel for the why wouldn't you want the solar panel for the washer and dryer to making the hydrogen? Because what if you're not using the washer dryer?
I'm saying you do both. I'm saying if during the day your wife wanted to wash clothes, right? Sun's out, she could absolutely just throw clothes in there without any worry of that system not working because she's going to have sun. If she decided to not wash clothes, that power could then be making hydrogen. Yes, it's a win-win.
But if the battery, okay, what's in between the solar panel? You have a hydrogen tank and you have a solar panel. What's in between that?
Say that again. I was reading something. Say it again.
You have to fill this tank. You have a solar panel and you have a hydrogen tank. What's in between that? You need to get the hydrogen.
Hydrogen tank. Yeah, you need to make a hydrogen generator.
How long do those last for?
Ooh, 10. A bad one will last 10,000 hours. A good one will last 100,000 hours before maintenance.
10,000 hours. That's it.
Yes, sir.
Are you talking about one that?
How many weeks? Hold on a second, Bear. Damn.
Go ahead.
I don't know how many days is that.
5 years, 10 years, because you're only running it during the day. Those are commercial. That's like people, energy companies that run those hydrogen generators all day long, every single day. They can go years between maintenances. So you only running it for 8 to 12 hours a day could go 5 or 10 years without any maintenance on it.
What's the maintenance look like on it?
You replace some membranes and replace some gaskets. Maybe I forget. It's either the anode or the cathode might leak. You might need to replace an anode or a cathode.
Are these things cheap in the first place, though, or?
Well, it's scalable. It's whatever materials, whatever design you go with. It's not like you have to do some research on it, which I've done.
Yeah, like how much would it cost? How much would it cost? Hold on there. Let me just finish this out, what I'm doing, and then you can do whatever you do. Give me 2 minutes. How much does that thing cost to make one or buy one? Say I want to buy a very good one. How much would I run you?
To do similar to him, to be able to fill up like 150 days,
160 days. Yeah, I want 2 months for 160 days.
That generator will cost you about $4,000, $5,000, $6,000. That's my guess to buy it.
And if you last 10 years.
Yeah, before maintenance, it's not like it's not rocket science. Like it's just bolts. There's just plates and bolts and membranes. So like once you know how to put it together, once you know how to take it apart, it will take you a half of a day to do the maintenance on it. It's not like I'm sure you've spent more time mopping your bathroom than than doing the maintenance on a hydrogen generator.
Because we don't have the Roombas going yet. But okay, I mean, dude, that's fucking expensive, bro. But after that, it's cheap. You're saying, and it's gonna last forever. That whole setup will
Sure.
last forever, basically,
Okay.
with maintenance.
Can I explain why, in your perspective, you're saying that's expensive? You're thinking about it from the perspective of one person buying it, one family using this technology. I'm thinking about it in the sense of, what if 6 or 10 or 8 families got together on one property and we build it big enough that every single one of us would have plenty of power for the rest of our lives and our children's lives, and split that cost? Because it will almost cost the same amount of money for you to build one for one family as it does to build one for a 10-person family, a 10-family
You're just
family.
talking a few more tanks.
It's a few
Just
more
a couple
plates.
more tanks, few more panels.
Yeah, that's it. So scalable, bro. That's what I'm saying. Like, so when you do the math on that, it's dirt fucking cheap.
Yeah, but you got to get 6 feet. You'd have to get like your block to go in on it with you, basically, the whole block or something.
Have you
Or
heard
a few
of
houses, your direct neighbors, something like you know. It'd have to be they'd have to be in a block of people that are down with it.
Have you heard of Project SMUD? SMUD.
No.
In Sacramento?
Hold
It
on one
was-
second. That sounds interesting, but just hold on one second. Let me just finish this out. One more minute. Or go ahead. Go ahead. Tell us what SMUD's about. We're not done with this Levelist. This ain't over.
I'll do better. I'll just pull up some literature and put it in the chat.
Okay, hit us with it real quick. What's it about?
Okay, it was a community in Sacramento that came together and agreed with a governing body that was, wanted to perform an experiment, and they invested, like the initial investment in the cost of having it right and installed, etc. Having a mutual network put up together, where eventually they were looking for return on investment to the point where they would produce more than they used and be able to feed back to the power grid and eventually just get paid.
Yeah, that's dope. That's dope. Some places don't do that though. Some places won't pay you straight up cash off the grid. Where I'm connected into the grid with my solar panels, and they won't give you cash. They give you credits.
Oh, well.
Some places will give you cash though. Bandsaw used to get cash. There's other states, places will give you cash. Some places won't though.
Maryland F's you. Maryland won't even let you get paid. Work credits. They fucking make you put shit all over your roof, right? Cover your roof with freaking solar panels, and what the deal is, it goes straight into the grid. You don't get any freaking credits, nothing. They just sell
Why would you even get
freaking
solar panels?
electricity. They sell you electricity at like a freaking 15% reduced rate. That's it.
All right. But Levelist, yeah, no doubt. Some places are weird, yeah. But
what I was thinking, here's what I was thinking, Jeremy, like going old school. Let's say we were trying to bring manufacturing back to America. We could go and we could get a 300, 400 watt DC motor. And, it's going to cost $4,000 for that motor. And then we could go spend $4,000 or $5,000 worth of solar panels, and we can directly connect this 300 or 400 watt horsepower motor up. And inside of our manufacturing plant, we could do like those. Have you ever seen those like turn of the century, like water mills and the different plants where they had one big motor and it was spinning the bar, the one cog, and then all the other machines inside that shop just had like a leather belt, and they would just direct hook up to the one shaft in the middle of the room.
Yeah.
And they would run their individual doodad sewing machine or drill press or whatever it was.
I'm just
and
trying to justify.
Like if you realize how much power, how many different machines could be directly driven off of a 300 or 400 watt horsepower DC motor when the sun is up during the day, you could have 15, 20, 25 workers in there working on their shit for free with no bills, no debt, nothing. Just producing. If the sun's out, we're out there working, producing shit, selling shit to better our community, our society. Not having to pay anybody a fucking thing. 350 horsepower. Do you realize how powerful a 300 horsepower? I did the math. It's going to be like 70 solar panels.
Dude, that's a lot of fucking solar panels.
Yeah, but it's like $6,000.
It's like a pallet.
746 watts.
Two pallets worth of. It's. I think it's what Syrus is talking about. The motor I'm talking about is a 480 volt. So what you do is you look on the back of your solar panel and you look at the what is it called? The fuck, I forget what it's called now. The max. There's like a max voltage on the back of that panel. So you just stack all those together. That most of them are around 40 amps. I think they're around 40, right? It's like, am I getting my terms mixed up? I think it's about
amps.
40 amps. No. Yeah, it's 40 amps. You want to match volts, like
volts. Yeah, they're about 600 Pmax, I think. Open circuit and there's closed circuit too.
Yeah, so you stack them in a way.
Usually, all of them you can hook them up in series up to 600 volts, no problem.
Boom. Exactly. So sun is out.
Sorry, go
ahead. That's how you know when you got to go to work. Everybody's got to wake up and get your ass out there and manufacturing something when all those machines turn on automatically. Get your ass out there sanding those stools and get yourself making those doodads and the widgets. It would be so much power that, you could literally have an entire shop and never have to pay a bill the rest of anybody's lives. Because none of that machinery is burning out anytime soon.
So why aren't you skipping all the hydrogen shit and just turn that movement into moving a magnet near copper?
Well, you're talking about that's electricity. What do we need electricity for? We've got 60,000 fucking volts of solar panels up there. We have electricity whenever we want it.
I don't know, dude. How do you make a dryer go? Like, you got to have like hot air for the dryer and shit. I guess you do a solar air heater. That's another good one. It's like the solar water heater, but with air.
That's the heat from a solar panel is literally the easiest thing to do. You just hook up that nickel magnesium wire, which is that's all that is inside of all your electrical heating elements. Remember those old electric stoves from the 70s, those coiled up? All that is just wire coiled up, and they're just like basically shorting out that wire. They're giving way too much electricity, and it just gives itself off in heat. So, if you're trying to dry clothes during the day, it's dead simple. You can make your own dryer for fucking dirt cheap. And I'm talking about one that will last 20, 30 years.
Yeah, I don't know, man. This shit's just complicated. I'm trying to justify not doing the batteries because they're so cheap and they last so long. Like,
I'm not saying not do batteries. I'm saying you just need less of them. There's no reason to go overkill on these huge battery banks if you have a bunch of hydrogen sitting around. Because that truly is on demand. In the middle of the night, you can turn that hydrogen. All you need is hydrogen and oxygen turns back into electricity. That's it. Simple, easy. Fuel cell technology.
What's the maintenance on that end? We didn't even get to that part. What's the maintenance on the back end where you got to go from the hydrogen to the electricity?
So my idea is the Toyota Mira. I think it's called a Toyota Mira. Was like the first popular hydrogen car. They tried to roll them out here in California.
We got to buy a car?
No, we have to buy the fuel cell from a car that was crashed, and you can pick them up for like $2 or $3 grand, bro. So it's like 100. Fuck, my numbers are fucked up. It's basically that motor. Jeremy, you cheap fucking bastard. Yes. You think technology is cheap, dude? What do you? No, they're $2, Jeremy.
Bro, the battery. Yeah, I know. I thought this hydrogen thing was gonna be like $10 or something because the batteries are so cheap. It just doesn't. it doesn't make sense to not use them.
I agree with you. If you have batteries, you should use them. But what I'm saying is like it's all synergistic. It can all work together.
This
You can have
hydrogen thing's going to take up more space than batteries.
No. Why?
How many hydrogen tanks are you going to have? One of those giant hydrogen tanks. What's up?
Probably like half. I'm thinking I would probably start with like 3 or 4 of those 1,000 propane tanks if I didn't do the smaller, higher pressure tanks.
Oh, that's more space than a battery bank.
Yeah, but I wouldn't be living on a 1/8.
That's gonna be tricky though. That's gonna be tricky
acre
though.
pad like yours.
The bigger the tank you go, the more pressure you're gonna end up with. So
well, those propane tanks are weak. Those propane tanks you can only go up to like 200 psi. But
you can welding have those outside though.
That wouldn't work for hydrogen,
and it's not taking up interior space.
Oh, they work for hydrogen. You just don't get a ton of gas inside those tanks. What was your question?
Yeah,
like
the pressure's going to be so low, and your cubic footage is going to suck.
But you can have the tanks out. So the difference is you can have the tanks outside where the batteries got to be inside.
Yes, and there's no right. Yeah, if you go on vacation. Well, I mean, everything's automated now anyway, so your batteries would be fine. But let's say something happened where your system got fucked up and you went on vacation for a month and you came back, all those batteries would be, they would be down to like halfway. Whereas all of your hydrogen tanks would still be exactly where you left them. And they would be the same thing 30 years from now as well.
How's your solar system going to get fucked up?
Exactly.
Why would your solar system get fucked up on vacation?
Well, batteries are not a great long-term storage of electricity. Those batteries need to be used. You can't leave them topped up all the time, and you can't leave them drained all the time. They need to be managed all the time. So, and if you're not doing anything to actively manage those batteries, they will eventually go bad or they will degrade. Whereas the hydrogen doesn't do that.
You get about 5,000 cycles. I reckon you can up to about 10,000 cycles if you reduce the voltage range on them, but...
Once again, Jeremy, I'm not saying eliminate batteries. I'm just saying reduce their usage and supplement it with hydrogen instead.
So you're saying completely get rid of batteries?
You still listen as good as ever.
Batteries are not good long term. It's like kind of actually how they use the power grid now with that big lithium battery in South Australia. They use it to just deal with the brownouts and stuff. It's a surge protection sort of thing. I wouldn't rely on it personally. If you're thinking like off-grid stuff, bro. Basically buying stuff in from China.
Levelist.
Sir.
Out of all the wild off-grid shit I heard from you, the molten sand is, I think for me, is king. Because I want steam. Because with steam, I can immediately, I can have my 483 phase immediately. So it's like, and however, I can size the system to whatever I want.
Yeah, why aren't you using
so that molten sand shit?
So the easiest way to do that, right? Would just
not yet. I just gotta look into it.
So it would cost you like.
I gotta get the heat. Well, look.
Listen. Let me try. Let me try to sell you on this. Here's what I would do if I was still.
All right.
I looked into that sand route.
I'm already.
I decided against
sold on it.
So
I'm sold.
First of all,
why?
When you're selecting your sand, you need to go with the smallest possible sand you can find. It heats up faster and it retains the heat better than larger grains of sand. So you're going to start there with the finest micro sand you could find. Second, what I would do is I would buy a couple pallets, or I don't know how big you want to make it. Let's say you buy one pallet of solar panels. It's going to cost you between $2,000 or $3,000. It's going to give you between 10 and 15 kilowatts worth of energy. What I would do is I would directly, without charge controllers, without battery banks, just wire those fuckers straight into that nickel wire heater, and you just put that, you wrap that all the way around, and your sand itself needs to be double, triple, quadruple insulated. I would recommend some type of an aero concrete
through the sand. You're snaking this all 3D throughout the whole area or volume of the sand.
Well, heat rises, so you want the majority of those coils to be on the bottom, but they could definitely be on the side. Well, you can have your sand above ground, or you can have your sand in the ground. I don't know. It doesn't matter. You can go either way. But what I'm saying is, you want fuck. What's the name of that? What's the name of that foamy concrete? Oh fuck! I used to look into it a lot.
Aircrete.
Yes, aircrete. There you go. I would recommend aircrete because aircrete is fireproof and
cheap?
insect proof. It's dirt cheap. Yeah, it's just Dawn dishwashing soap bubbles mixed into cement, with a couple other ingredients. So you build your foamcrete. So you all of your sand will stay inside of that foamcrete, and then on top of that, what I would do is I would wrap that aircrete. So you go like 6 or 8 inches deep, thick of aircrete. Put your sand in there. I'm thinking of something the size of like a refrigerator, or maybe 2 or 3 refrigerators worth of sand. That's what I'm picturing in my mind when I'm describing this. So I would go like 6 or 8 inches worth of aircrete, and then on the outside of that aircrete, I would wrap another 6 or 8 inches worth of foam, just EPS. The same shit that your refrigerator and your TVs get packed in, the white soft foam. That's all. Yeah, we're wrapping that on the outside because it will be exposed to less heat, right? The heat will be on the inside. And then we're just wrapping the shit out of all that. And then you will need, your plumbing system, because you can get all of your hot water needs met with this same exact device. So you'll be plumbing your copper into the side of that. And then you run that copper into your water heater. So it'll, feed back and heat your water heater. But there's your massive sand, and that will be able to be heated up to 800, if not 900 degrees Fahrenheit without that sand turning into silica.
Right,
to glass.
2 things. I forgot the first one. We'll just start with the second thing.
That was all for Syrus, by the way. Why are you talking, Jeremy?
Where do I make? Well, okay, go ahead. I have 2 things. I already forgot the first one, so if we wait any longer,
you don't like the sand?
No, I love the sand. Oh,
the problem is the heat exchanger. Because I want to go steam, right? I want to go from the molten sand for me, molten sand to steam turbine to my mega 3-phase system. So for me, it's like that way you can just run it 24/7. You got 2 of them, obviously. When you shut one down to do the maintenance on that, it's really expensive, but man, you can have a lot of power stored for cheap. And just go underground and none of that fancy shit. All sand, sand insulation, and sand, and you add flux next center. Flux will help you out. There you go. You don't need micro sand, and we're gonna keep that shit molten.
Yeah,
molten.
I remember the
Let's
thing.
go.
Oh, okay.
I remember both the things real quick, guys. Real quick. I remember both my things. One of them I'm picturing way bigger than the thing you said, than 3 refrigerators. I'm picturing like multiple shed sizes, small sheds or something.
Ooh-wee.
Yeah, pretty big, just buried under. You just have it in the ground. And the second thing is, where do we have the Fresnel lens hitting this?
No Fresnel.
Why?
Solar panels.
What temperature?
You want to get sand hot. Why would you not use a Fresnel lens?
It's all encapsulated and under earth or something. It's not open to the direct.
Can't we take the heat from a Fresnel lens, have it hit a pipe and go into the thing or something? I don't know. There's no way.
Same answer twice.
Yeah. Maybe fiber optics or something.
I just don't know why we
I don't know.
Why we wouldn't use.
You might have to look into that. Got to track
what temperature?
The sun.
Hey, what temperature did you need to hit, Syrus? I didn't know you wanted to actually melt the sand.
Oh,
you're making glass.
Right around. Yeah, about 1,000 C. Keep it around about 1,000 C.
That's
because
massive.
I need about 500 C for superheated steam. We're talking a proper steam system, what I mean? Like
massive upkeep.
500 bar, serious steam, dude. We're not joke here.
Massive upkeep, dude. Massive upkeep.
With
that kind of pressure, you're looking at replacing valves constantly.
I understand. I did this for my. I did this for my final year project. Trust me, there's some tricks up thy sleeve. Okay, I want superheated steam. No, you don't have to run superheated steam. You can run it at much lower pressures. But if you go with the stainless route, invest at once, You're good, man. Like, you know, it's
That's
not the
not how it
1800s.
works. I
It's not
promise
the
you.
1800s,
The
sir.
weak point in your whole system is going to be every valve.
Okay, so there is however many hours those valves are rated for, you swap them out. So
How many hours?
And the pressure and the heat is going to be your big killers.
But you can have the tanks out. The difference is you can have the tanks outside where the batteries got to be inside.
Yes. And yeah, there's no right. Yeah, if like you go on vacation, well, I mean everything's automated now anyway, so your batteries would be fine. But let's say something happened where your system got fucked up and you went on vacation for a month and you came back, all those batteries would be, half. They would be down to like halfway. Whereas all of your hydrogen tanks would still be exactly where you left them, and they would be the same thing 30 years from now as well.
How's your solar system gonna get fucked up?
Exactly.
Why would your solar system get fucked up on vacation?
Well, batteries are not a great long-term storage of electricity. Those batteries need to be used. You can't leave them topped up all the time, and you can't leave them drained all the time. They need to be managed all the time. So, and if you're not doing anything to actively manage those batteries, they will eventually go bad or they will degrade. Whereas the hydrogen doesn't do that.
You get about 5,000 cycles. I reckon you can up to
they
about
don't last.
10,000 cycles if you reduce the voltage range on them. But
Once again, Jeremy, I'm not saying eliminate batteries. I'm just saying reduce their usage and supplement it with hydrogen instead.
So you're saying completely get rid of batteries?
You still listen as good as ever.
Batteries are not good long term. It's like kind of actually how they use the power grid now with that big lithium battery in South Australia. They use it to just deal with the brownouts and stuff. It's a surge protection sort of thing. I wouldn't rely on it personally. If you're thinking like off-grid stuff, bro. Basically buying stuff in from China.
Levelist.
Sir.
Out of all the wild off-grid shit I heard from you, the molten sand is, I think, for me, is king. Because I want steam. Because with steam, I can immediately, I can have my 483 phase immediately. So it's like, and whatever, however, I can size the system to whatever I want.
Yeah, why aren't you using
so that molten sand shit?
So the easiest way to do that, right? Would just
not yet. I just gotta look into it.
So it would cost you like.
I gotta get the heater. Well, look, that's pricey.
Listen. Let me try. Let me try to sell you on this. Here's what I would do if I was still.
All right.
I looked into that sand route. I decided against
sold on it.
I'm sold. First of all,
why?
When you're selecting your sand, you need to go with the smallest possible sand you can find. It heats up faster and it retains the heat better than larger grains of sand. So you're going to start there with the finest micro sand you could find. Second, what I would do is I would buy a couple pallets, or I don't know how big you want to make it. Let's say you buy one pallet of solar panels. It's going to cost you between $2,000 or $3,000. It's going to give you between 10 and 15 kilowatts worth of energy. What I would do is I would directly, without charge controllers, without battery banks, just wire those fuckers straight into that nickel wire heater, and you just put that, you wrap that all the way around, and your sand itself needs to be double, triple, quadruple insulated. I would recommend some type of an aero concrete
through the sand. You're snaking this all 3D throughout the whole area or volume of the sand.
Well, heat rises, so you want the majority of those coils to be on the bottom, but they could definitely be on the side. Well, you can have your sand above ground, or you can have your sand in the ground. I don't know. It doesn't matter. You can go either way. But what I'm saying is, you want what's the name of that? What's the name of that foamy concrete? Oh fuck! I used to look into it a lot.
Aircrete.
Yes, Aircrete. There you go. I would recommend Aircrete because Aircrete is, fireproof and
cheap?
insect proof. It's dirt cheap. Yeah, it's just Dawn dishwashing soap, bubbles mixed into cement, with a couple other ingredients. So you build your foamcrete. So you all of your sand will stay inside of that foamcrete, and then on top of that, what I would do is I would wrap that Aircrete. So you go like 6 or 8 inches deep, thick of Aircrete. put your sand in there. I'm thinking of something the size of like a refrigerator or maybe 2 or 3 refrigerators worth of sand. That's what I'm picturing in my mind when I'm describing this. So I would go like 6 or 8 inches worth of aircrete. And then on the outside of that aircrete, I would wrap another 6 or 8 inches worth of foam, just EPS, the same shit that your refrigerator and your TVs get packed in, the white soft foam. That's all. We're wrapping that on the outside because it will be exposed to less heat, right? The heat will be on the inside. And then we're just wrapping the shit out of all that. And then you will need, your plumbing system because you can get all of your hot water needs met with this same exact device. So you'll be plumbing your copper into the side of that. And then you run that copper into your water heater. So it'll, feed back and heat your water heater. But there's your massive sand, and that will be able to be heated up to 800, if not 900 degrees Fahrenheit without that sand turning into silica.
All right,
to glass.
2 things. I forgot the first one. We'll just start with the second thing.
That was all for Syrus, by the way. Why are you talking, Jeremy?
Where do I make? Well, okay, go ahead. I have 2 things.
Go
I
ahead,
already
man,
forgot
if
the
you're
first
not-
one, so if we wait any longer,
you don't like the sand.
No, I love the sand. Oh,
The problem is
I
the heat
remember the first one.
exchanger. Like, because I want to go steam, right? I'm going to go from the molten sand for me, molten sand to steam turbine to my mega 3-phase system. So for me, it's like that way you can just run it 24/7. You got 2 of them, obviously, when you shut one down to do the maintenance on that. It's really expensive, but man, you can have a lot of power stored for cheap. And
I
just
get
go
3.
underground and none of that fancy shit. All sand, sand insulation, and sand, and you add flux next center. Flux will help you out. There you go. You don't need micro sand, and we're gonna keep that shit molten,
Yeah,
molten.
I remember the
Let's
thing.
go.
Oh, okay.
I remember
didn't know
this.
you were
I
wrong.
remember
gonna
both
be-
the things real quick, guys. Real quick. I remember both my things. One of them, I'm picturing way bigger than the thing you said. Than 3 refrigerators. I'm picturing like multiple shed sizes, small sheds or something.
Ooh-wee.
Yeah, pretty big. Just buried under. You had just have it in the ground. And the second thing is, where do we have the Fresnel lens hitting this?
No for now.
Why?
Solar
Why?
panels.
You want to get
Good to
you want
hear.
to get sand hot. Why would you not use a Fresnel lens?
It's all encapsulated and under earth or something. It's
but
not
can't we
open
take
to
the
the
heat-
direct.
Can't we take the heat from a Fresnel lens, have it hit a pipe and go into the thing or something? I don't know. There's
Did you
no
get the
way.
same
to-
answer twice?
Yeah, maybe fiber optics or something.
I just
You
don't
can
know why
pipe
we
it. I
wouldn't
don't
use
know.
why we wouldn't use
You might have
Fresnel
to look into
lenses.
that. Got to
What
track the
temperature?
sun.
Hey, what temperature did you need to hit, Syrus? I didn't know you wanted to actually melt the sand.
Oh,
You're making glass
Yeah,
or
right
something?
around.
melted.
Yeah, about 1,000 C. Keep it
What's the
around
way?
about 1,000 C.
That's
Because
massive.
I need about
great.
500 C for superheated steam. We're talking a proper steam system, like what I
Bro,
mean,
that's
like
massive upkeep.
500 bar, like serious steam, dude. Like we're not joke here.
Massive upkeep, dude. Massive
Maintenance?
upkeep. You're dealing with them
Maintenance? What's
temperatures
upkeep?
and that
Maintenance?
kind of pressure. You're looking at
I know.
replacing valves constantly.
Constant
Yeah.
maintenance. Oh, dude, this is
I
terrible.
understand.
This is a
I
terrible
did this for
system,
my.
Cyrus.
I did this for my final year project. Trust me, there's some tricks up the sleeve.
You
Okay,
ain't got
I
none.
want superheated steam. No, you don't have to run superheated steam. You can run it at much lower pressures. But if you go with the stainless route, invest at once, you're good, man. Like it's not the
That's not how it
1800s.
works.
It's not
promise
the
you.
1800s.
The
sir.
weak point in your whole system is going to be every valve.
Okay, so there is however many hours those valves are rated for, you swap them out. So
How many hours?
And the pressure and the heat is going to be a big killers.
How many hours
dude,
we got in the valve?
it's an expensive. I never said it's a cheap system. Remember,
What
let's
are you doing
rewind.
with this?
Yeah, I
This
was
is
thinking you were.
expensive. This is
I was
real
thinking-
power.
Yeah, I was thinking you wanted to just like run your hot water and maybe sit some Stirling engines on top of there to get some electricity off of it.
That's what's up, Stirling engines.
That's okay. That's small power. You
Right.
know what? 10 kilowatts or whatever.
Yeah.
But
What are you powering,
if
dude?
you,
What are you
He's
trying to
making
power?
a mini power plant, dude, is what he's
What the
doing.
whatever, why more power, more money, more better, bro.
What you gonna do?
Well,
Rockefeller
better.
never thought that way. Go bigger. Like what the fuck? Why not? Oversize it. Who cares? Build
Did
a
any of you
100
guys
kilowatt
watch?
system. Why
What?
not?
Fuck
Did any of you
the
guys
power
watch
plant.
Levelist
You
video
become the
yet?
power plant.
That's what I'm talking about.
Hold on, somebody's trying to get in. Go ahead.
Did any of you guys watch Levelist video yet with the hydrogen?
Oh, what's up, Fundy? No, I don't. I don't watch any of his videos. I did watch one video he sent me once.
Oh, I mean, it seems pretty hard to beat that guy's setup. I mean,
Is it
he's
the
just got a
hydrogen
few.
tanks?
Yeah, he's just got a few solar panels and some water, and it just fills up these giant hydrogen tanks for
Just
him.
rain. He's just collecting rainwater.
Hey, by
I'm
the
not sure
way,
where he gets
see,
the water from.
Fundy, by the
Where's he
way.
getting the
So,
water from, bro?
hey, listen. See, so look at that thumbnail I just put in there. This is the guy. By the way, do you know how cheap those were? Like $60,000-$70,000 cars when they came out. Do you know how much you can pick up those Toyota Miras for right now in California?
Do you want me to guess?
We gotta buy used cars
Please,
for this.
please tell me
I,
how much you think
I'm
that car cost with 20,000
I'm
miles on it. By the way,
I'm gonna guess a used version. I'm gonna guess 1500.
4,000, 1,500, no, $4,000.
That's crazy.
Did
Wow,
you say
that's
You can buy
1,500
the
bucks?
incredible.
whole
It's a
car.
luxury car. It's a luxury. It should say
You can buy a
Lexus.
whole car for 4Gs.
It's a hydrogen car. That's like the first real popular hydrogen car. You could pick up a 20,000 mile hydrogen car. It's a fucking luxury
Where
car
do you fuel
for
that at, though?
$4,000.
Where do you even fuel that?
Your own hydrogen power plant
How
is
many
where you
miles
fuel
you
it.
get? How many miles you get to the tank?
He
I
said
think it was
300.
like
He said 350.
Yo, that's crazy. That's pretty good. You can't go on no long trips, but you get to work and back, no doubt.
Well, here's the thing, right? He said it takes as long as there's a hydrogen refuel station. I know those aren't common, right? So that's the fucking linchpin. But it only takes 5 minutes to refuel from empty to get another
Yeah, but
350 miles.
you could do it at your house though and go to work and back all day on that.
Absolutely. And you're making it
4Gs,
yourself with your own water just out of the creek or something.
word
Solar
rainwater off
panels
the
and a
tap,
creek.
word
Yeah,
right off the
Hey,
tap,
that's a good
probably.
funny.
setup.
Did you see the thing where he put the converter in the back and he's like, I could power like 8 houses off this car
Yo,
alone?
what's the name of this car? What's the name of the car, bro?
The Toyota Mira, something Mirai, Toyota Mirai.
Spell it.
But
I'm
I don't know.
terrible. It's Mirai. You'll find it.
Yeah, it's probably got 100 kilowatt fuel cell in it. Something like that.
So he's
115,
so three.
115. Yeah, and the new one has 170.
You know
The
what?
old model,
See?
the first model, it's like the 20,
What year
like
am I
12.
looking for?
I think they
2012?
were from like 2012 was the first one, and the new one came out in like 2017. But the first one had like 118 kilovolts, and then the new one has like 170,
Bro, what year is the
If
$4,000 car?
like a 2015.
Oh, that's pretty old. That's a pretty old car.
So you don't know how to work on cars for shit.
Four
Then, huh?
Gs though. Yeah, I don't do a lot of car stuff. For 4Gs though, that's pretty fucking cheap. Especially if you're
Yeah,
gonna make your own fuel. You have no gas. You won't have to pay gas. I mean, how many solar panels we need to?
What do you think is
How
going to
many
go wrong with a 20,000 mile Toyota? Are you familiar with the car company Toyota?
Yeah, no. How many? Here's my next question. I hear you. It's probably dope. 4Gs is a good get. That's why I'm interested. How many solar panels we need if I want to go?
based
Let's say I want to go
based on the
50.
video,
Go ahead.
he sent of this guy explaining it. The guy had about 12 solar panels that were all about like just guessing, eyeballing it like 3 by 2 feet, so like 12 of those sized ones. And he
No.
said that in
Oh, you
I mean, that's what he showed. I mean, he also did have these like thin ones that don't do as much. He had like a whole
Levelist.
wall of those, but
Levelist. I want to go
still,
50 miles. I want to go 50 miles a day. I'm in this car. How many solar panels I need?
what'd you say? Say it again.
I want to do 50 miles a day in this car. How many solar panels do I need?
I don't know.
let me
Yo,
put it
that'd be
this
a
way,
dope
right?
ass system to have,
Let,
dude. Never
let,
having to buy gas again. Do you know how
yeah,
awesome
but
that is?
it's
Let-
scalable. Like I said, it's almost the same amount of money to build a system for 25 people as it is to build a system for 3 or 4 people. So it's like, you might as well.
So I talk mad people into getting these cars, these 4G cars, and then we all just have free gasoline. That's it.
Yeah, he's got way more than yeah. See, I have it. He's got about 60, 70 panels, Fundy. It's about 25,000 kilowatts.
You ain't gonna need that for just a car though. If you were just doing like 50 miles a day or something.
Let's put it this way, right? He said he made his own. He converted a golf cart into being hydrogen powered, and he said it gets 200 miles on a single charge, and that it charges itself up with a single solar. All it needs is about a 6 foot by 3 foot solar panel on the top of the golf cart, and all he has to do is put water into it because it makes its own hydrogen as it just sits in the sun.
Cooking, bro. Now we're talking. This is fucking huge. You lace the car with solar panels, the roof, the hood, the trunk, the side panels, the doors, everywhere there's not glass or a headlight or something, you put solar panel on it. And now we're like Back to the Future where he's getting garbage, except we just need water.
Hey, you stick to being an economist. You're not much of a fucking engineer.
Economist. So. Listen, it's not important.
Yeah, that's
the important thing is you could put the solar panels on the car and just make the hydrogen right there. Could you?
Yeah, the
could
golf
you fuel
cart
the
design
car?
he has is where it's at.
Levelist, can I fuel this $4,000 car without having to just lining it with solar panels? How about you just get one solar panel on the roof in the trunk?
No, it's only the one modern panel is like 400 or 500 watts. You ain't doing shit with 400 or 500 watts.
How much hydrogen does that make? I only want to go like 50 miles a day. I'll make sure this thing's cooking in the sun all day, pretty much. You ain't doing nothing with that? If I put a solar panel on the roof? How many miles could I?
He said in 3 months.
You should just get a veggie diesel, dog. I drove one an old Mercedes that was veggie diesel.
Yeah, I almost did that.
Not a bad idea.
I almost did that.
10 years.
I had a Volkswagen Jetta. I was going to turn into they sold a system where you could take used fryer oil from like restaurants and shit because they used to pay to get rid of that. Now they sell it, but yeah, I almost bought a system like that.
I mean, it's cool. The car I drove though, it kind of smelled like French fries, but it was dope.
Yeah. Nah, it's cool shit. I like this hydrogen thing though. It's clean. All you need is water and shit. Like how many Levelist, realistically, 50 miles a day. How many solar panels?
I'm gonna be honest. The hydrogen is a pretty expensive upkeep. It's gonna take like 25 grand to put a proper everything you need for the hydrogen between the massive solar array,
fuel a whole house,
between building the actual hydrogen generator itself. It's going to cost you another, like I said, between 4,000 and 6,000. Your tank storage and all of the piping and valving to go with that's going to cost you another 5,000-6,000. And then if you wanted to then turn that hydrogen back into electricity, you're going to need to get a fuel cell. A fuel cell is going to cost you another $5,000-6,000. So but after that $25,000 is spent, there would literally be no more bills, no more fees, and you would be in the clear for the next 25, 50 years.
How much would maintenance be on that system a year?
Like next to nothing. The way you're going to use it.
How much would the conversion cost? Like the conversion to get the hydrogen into the tank from the point of the hydrogen
pretty good, 60%
to in the tank.
You get all of it. You get nothing because you're getting it from the solar panels. You're getting a direct.
You still have to like pressurize it and send it into the tank. Like that.
Yeah, you get a compressor. Yeah, your compressor will cost you. A decent compressor is $2 grand probably.
It's all done. It's all done on the part where you have your home base water tank, and then you have your home base hydrogen tanks, right? And you have your electrolysis, water to hydrogen converter, right? It pressurizes your tank of hydrogen gas at your home base. And then all you do is flip a valve and equally pressurize your inside of your car's tank to the same degree that the tanks that are already pressurized have. It just gets an equilibrium. So it doesn't take any extra effort to like pack it tight into your car's tank. That job has already been done.
It takes extra money to filtrate the water out of the gas when you go to pressurize it.
Yeah, you have to run it through
Otherwise,
desiccant.
you're gonna fill your tank with like the bottom's gonna be all water, and then it's just gonna rot out.
Yeah, you have to run it through your two towers, your H towers. The one will split off. I forget. I'll get it mixed up. But the anode produces the oxygen. It runs back into the actual water tank that's feeding your electrolysis system. The cathode is producing the hydrogen. It runs up into another water bath, stripping off any water that was left over. Then it runs in through a desiccant. Basically a desiccant, a dryer. It just completely dries it, gets it up to 99.99%, and then it runs into your compressor, and your compressor sends it to your tank. Now, your first question, I thought you were asking how much of the losses when you're turning your hydrogen, once you're trying to run it through your fuel cell to get electricity, what are your losses or the efficiency? The fuel cell is only about 65% efficient.
Yeah, I was thinking more like the cost from that phase to the tank, from the whole phase, from the solar panel to the tank, everything in between. I was wondering what that price point would be. It seems like that's going to be the majority of your costs.
Yeah, 12 to 15K. That's my guess, my rough guess right now. There is a guy in Europe.
Itself would be a lot cheaper.
Of course.
Like, I don't know why you're not buying one of these hydrogen cars.
If you buy a bunch of used stuff, it'll be even cheaper. Build it yourself with used parts. Now we're talking.
Oh, I wouldn't go used. I would never go used with piping systems.
Well,
not for pipe,
this,
but
like that.
Compressor.
If you have this whole hydrogen system, if you have this whole hydrogen system set up, why would you not get a hydrogen car?
Exactly.
Well, do you drive cars or do you just walk places? Like, what do? You got an e-bike?
Horse and buggy.
You skateboard? They got like electric unicycles that are no joke. That's how I picture your transportation is on one of those.
They do. Those new electric bikes are pretty dope. I do plan on getting one of those badass, like 45-mile-an-hour electric bike.
Bro, that's the way to travel, dude. You're gonna tell me you're supposed to be driving a 3/4 ton vehicle around to move your little 200-pound ass. You know what I'm saying? Like that don't make no sense.
Look at that system. That's like a little mini micro. I forget where I found that video, but that's a little mini hydrogen system right there. You could buy that from China, I'm sure.
You got to get a hydrogen powered car if you need a car. Like you'd have to.
I'm going to be honest. I'm more intrigued by the turning it back into electricity whenever I want to phase. But yes, you're right. Hydrogen is very useful in anything. You could cook your burgers with hydrogen. You could heat your house with hydrogen.
Like without even having
many uses. Yes, I agree with you.
Man, it just produces water and oxygen.
If you could fill your fuel up and you don't have to buy gas anymore, I mean, gas isn't getting cheaper, and you'd save like thousands of dollars a year just on not having to buy gas, probably.
So, like I said earlier, you become the power company, you become the gas company. If you have your own well, you become the water company.
Something directly related. Are you familiar with aqueous fuels? Okay. Weird word.
Say that word again.
Water fuel. Or water fuel mixture. Anything like that?
Tell us about
it. There's a couple of brothers worked in fuel industry, and they're working on removing the sulfides, sulfur from the. Well, anyway,
you started all the way at the beginning. All right.
Yeah.
I mean, just give us the gist of it.
All right. The patents filed, and the demonstrations of Rudolf Gunnerman, specifically, had regular gasoline running with 55% water in the mixture, but he could get some like high pro moonshine and get up to a little over 70% water, and Anyway, let me go ahead and just drop something in the chat. That way, you don't have to just take my word for it.
I don't even know what you said. What's going on with the fuel? Water fuel? So take a moonshine, mix some water with it, and you can put 70% water and use it to run an
Right.
engine.
I mean, you can. They were able to take the gasoline at the time that was available, and have a mixture with 55% water.
Yeah, I don't know if you want to be doing that though, and I mean maybe for something inside of a controlled climate or something, you don't want to be doing that in
Well,
upstate New York in the wintertime.
right. There's conditions that
You could pull
you
that off
have to
inside a
take in.
house, inside a controlled
Well,
environment,
definitely.
a
That's
climate
why
controlled.
his first practical demonstration was what we call a generator, right? But anyway, yeah. Let me go ahead and I'll just drop a little bit of literature. Which goes
Yo,
by fast.
I'm saying, dude, like people are spending like a lot of money on fuel for your car, bro. If you had the friggin' hydrogen thing and you had it be the fuel for your car, that's pretty sick. Like that's no joke right there. Like I don't know.
Well, yeah.
You
He
just
started. He filed his patents in 1989. So I think those patents are up now.
I mean, you could take a pen and just make the shit yourself. As long as you don't sell
Exactly.
it. As long as you don't sell it,
Exactly.
you're good.
Yep. And I think that's the reason he did what he did, was to get a heads up that, hello, this is one way to go. The introduction of platinum, a noble metal, kind of brings memories of Meyer's noble gases. And well, anyway, yeah, there's a lot of people that have been working on similar stuff, and there's probably a whole group of people that's been working on this research right here, or a whole group of them probably have it way more refined nowadays.
That's pretty neat. I mean, you can't. It only has certain uses, but I can't stop thinking about these cars with the hydrogen. Like, dude, if you and your wife had this, and you spend like $100 a week on gas, and now you get these cars, and you don't have to spend $100 a week on gas. That's pretty big. It's $400 a month or something.
It's
And
$5,200 a year.
that's what I'm saying. That's vacation money. And then your brother-in-law and your cousin and your little nephew and your your all your people. You're like, yo, guys, build these buy these hydrogen cars. I'll fill them up for you for nothing. You know what I'm saying? I'll just get a pallet of solar panels and we'll have free fuel forever or chip in or whatever. Here, just come fill your shit up in my driveway or whatever. That'd be so crazy.
Yeah,
Like everyone pitching.
you got some solar panel powered hydrogen gas making and a car that runs off of it. And the guy in the video, he runs his house off of his car. He says a single fill up of his car can run his house for 32 weeks. You hook up some geothermal fans on top of that. Now you're heating and cool. I mean, he's already doing that, but even more efficiently, you know, 3 months of solar panels making hydrogen gas with a better house design with some proper insulation built better with thermal mass and maybe some geothermal stuff. 3 months might power all your house needs for fucking 10 years or something.
Like if you wanna
Yo, Levelist.
Yeah.
Yeah, good. Yeah, man, that's not. I mean, yeah, I like that system, but steam is invisible. Consider that water vapor. So you can see it. It's
Okay, but
technically water vapor. It's
that
not
No,
steam yet.
steam's visible. Water vapor
the
is
reason
invisible.
the reason that one was dope is because I was going down my Tesla turbine rabbit hole, and that is like literally perfect for a Tesla turbine.
Yeah. Oh hell yeah. So, absolutely, bro. I mean, look, I'm not gonna start a war in thermodynamics. Just pull up a thermodynamics book, look at the steam tables, or go on the index, look up steam, and
What's the
see if
white
it's
shit that
visible
comes
or
up?
invisible.
What's the white shit
Water
that comes
vapor.
out of a
It's not
no
steam
water?
yet. It's water
So
vapor.
what temps? You're saying
No water
it takes
vapor.
1,000 degrees to
Hold
get
on,
that?
man.
Bro,
Can I just get this
okay,
sorted out real quick?
superheated steam. Let's sort this out. Superheated steam will catch wood on fire. It's invisible. You open a tap, you put a piece of paper there, ignites. That's steam. Specifically superheated steam. So your eye cannot see it. Even when it exits into the air, it is fucking invisible and it'll burn the shit out of you. It will turn steel red hot. It's like 500 degrees C.
So what produces that
That's
right
cherry
now?
red.
Where can I see examples of this?
No, I have a
What
definition
machine?
So
right
all you
now.
have
You're
to
not
do,
getting.
you
Can
saw
you guys
that
hear me?
turbine.
Yo, can you
Yeah.
guys hear
Any
me?
boiler does that.
We're ignoring you, Jeremy. Go ahead, sorry.
Well, you're getting it wrong. Steam is visible. Water vapor is invisible. I have citations and definitions right now. I'm going to drop in the chat for steam.
Oh fuck.
Yeah,
I don't know why
whatever, bro. We're
I don't know why
dealing
you're
with
getting this
actual
simple thing
steam
wrong.
systems. Who cares? Who cares, bro? Go look it up. YouTube superheated steam. You'll see people lighting shit on fire with it. You can't see it. It's okay. It doesn't matter. We're talking
It's not
engineering
steam, then.
steam. You can
It's not steam.
physicist steam is irrelevant to us. We're not gonna fight about that. Anyways, so you saw that guy in the video. You saw that water vapor coming out. That steam. That's not steam that you can see. All you have to do is take that and heat it some more. Okay, before you let it out of the valve into a turbine, right? You got to heat it some more, so you can have another stage of heating right after that, which essentially is going to bump up the pressure of the overall system. That's why a boiler is under high pressure, because to keep the water from boiling at 100 degrees C, right? You got to trap it at ridiculous pressures, and it's not going to boil. It's going to turn into superheated steam, right? When it's that hot.
Skip
and
the
it's
phase
under
change.
ridiculous pressures.
Yeah, it skips one of the phases of the changes.
It will phase change into steam, and it will get superheated still above that, right? And then it becomes totally invisible to the naked eye. You cannot see steam. Superheated steam is invisible. It is not visible.
I'm waiting for Jeremy to correct you.
So that's what they run the like commercial turbines or whatever, back in the days, whatever. So I mean, till today, but all the steam powered engines, yeah, like back in the James days, or your tractor runs on steam.
No,
well, the idea
even
is
nuclear.
to get superheated steam.
All of our nuclear plants are still powered on those same exact turbines. Yeah, that's what the nuclear is doing. The fission is causing that steam, and it's still powering turbines from 150 years ago, 200 years ago.
100%. Coal and nuclear both are kettle. Essentially putting all that heat into a boiler, running an efficient turbine. So steam is still quite efficient.
Dude, I just found a citation saying what you're saying, but they're saying water vapor. They're saying water vapor is visible, but it's not. It's an invisible gas. Water vapor is an invisible gas, right?
Water vapor is visible in the air. When we talk about steam,
water vapor
we're discussing
water vapor is visible. That's what you're saying.
Yeah, like when you're boiling water, you see that white cloud that comes above. That's water vapor.
Steam is the next step on top of that.
Exactly. Take that vapor, heat it some more, hit it with a torch and a pipe. Now, when it exits that pipe, it's going to be invisible.
Water vapor.
It's not going to be white anymore.
Water vapor is a colorless, transparent gas.
Cool. So why can you see the droplets in steam?
Because when it's steam, it's not gas. It's not water vapor anymore. It's formed into very small, very tiny water molecules.
Okay, that is not steam.
Water vapor is
Isn't
an
water
invisible
vapor
gas.
like?
And that's the colloquial steam. That's when you
water
boil,
vapor is an
your
invisible
cup of
gas,
coffee
though.
shit.
I know, but
Isn't
water
water
vapor is
vapor
invisible.
constantly coming off of water?
Yep.
Yeah, dude, water vapor is invisible. You can't see it.
Whatever, man.
It's constantly coming off again. What am I looking for over a cup of water? What should I be seeing?
You're looking droplets. You're looking at droplets, right? Suspended in that vapor, and you're gonna call that thing steam. And that's not steam.
No, I'm talking about
Or
the
not
water
yet.
vapor. When evaporation happens and I'm looking at a cup of water, what should I be seeing?
It's just condensed, is what you're seeing. You're seeing it condensed.
You're not
But when
seeing
it
anything.
actually
You can't
turns
see
into
water
the
evaporate.
vapor, yeah, when it
can't
turns into vapor, it's going to be invisible. It's a gas.
That's what I said. That's what I'm arguing for. Water vapor is invisible.
But it's in a state, right? So like you see how it condenses, right? You kind of see that process, but you don't see it when it
You see it,
finishes
but
the
you don't
process,
see
I
it.
guess.
No, this is brilliant. I'm getting my wife for this one. Hold on. You see it, but you don't see it. I wrote
No, you
that
see the
down.
process happening, right? And that's when it's condensing, right, into a gas, right? Wouldn't you say that's accurate?
I don't know, bro. What? I don't
Yeah,
see anything
it's going
happening
from a
over a
liquid
cup of
state
water
to a
when it.
gas state, and then you see
Yeah,
the steam, which is still the like water vapors, right? But it hasn't fully turned into a gas yet, so you
dude,
can
you
see the
can't.
steam.
You can't see water vapor. I'm saying my
I
argument is
just
you
said
can
that.
see. My argument is you can see steam and you can't see water vapor. Cyrus is saying the exact opposite. I don't know why.
I'm just saying what he's talking about is like while it's condensing.
No, you can't. You can never see water vapor. It's invisible. If you're seeing it, it's
This.
turned into
Hold
steam,
on.
which is tiny molecules of water now. I know this for a fact because you can
Yeah,
put your hand over it and your
the
hand
steam
gets
is
wet.
not vapor. The steam isn't vapor. Like
I know it's water
when you see,
molecules
right?
and
It's
it's
just like
visible.
I mean, yeah,
You're on my
it's
side. Just hold on. Just relax.
I'm trying to tell him what he's seeing is he's seeing the state of, when it's condensing. It's just switching states and you can see it happening before your eyes. But once it finally happens, you can't see it anymore
And it's
because we
water
can't see
vapor. You
gas.
can't see it. Yeah, you can't see water vapor. I know. But I just found a citation backing up what Cyrus said that you can see water vapor. I don't know why people are saying you can see it. What am I supposed to be looking for over a
Yeah,
glass
but he
of
can see
water?
steam.
Bro. I'm talking about the colloquial fucking steam off of your
Yeah, you can see
like
that. You can
cup of
see.
coffee.
Don't let him bullshit you. You can see
You're
steam.
seeing water droplets. That's not steam. Because steam is water vapor, superheated water vapor, so you can't fucking see it. Is what I'm saying.
Can't you
Rewind
can't
one more
see water
fucking
vapor.
time.
You
Water
can't see water
droplets
vapor.
suspended in the water vapor. But okay, you're seeing actual droplets off of your boiling water, right? That's not steam. That's colloquial steam.
Okay, but we agree you can't see water vapor, right? That's invisible.
Yeah, when you
Yeah,
see the steam, it's not
you're
vapor.
seeing droplets of water. Those are actually suspended droplets. You can zoom in on it and see the magnifying glass, like smoke.
Yeah, your hand
It
gets
is
wet. I know that's
condensed.
water.
Okay, now steam is totally invisible to the eye. This is where you start disagreeing, correct?
No,
I
you
don't
can
know
see
because you were
steam.
talking about superheated steam. That may be
Oh,
that
you
may not
can
be
see.
visible,
Stop
but
it. You can see the
regular
steam, dude.
steam,
Stop.
regular
You can
steam
see
you
the
can see.
steam.
But
Stop it,
you're
All
Jeremy.
right,
talking
all right.
about
I think
superheated.
you guys think you guys need a video? All right,
Jeremy's
well, let me
working
get a
his way
video.
back up the Glober leaderboard right now.
Give me a
I'm
second.
just saying I don't know about superheated steam. I know regular steam from a coffee pot or a tea kettle or something. You can see that steam because it's actual water droplets. It's not water vapor, which is invisible.
Oh, so you can see steam?
I say you can see steam. Yes. Why are you always trying to argue with me?
Dude, I'm not trying to argue with you. I'm trying to clarify so you guys can find some common
I'm
ground.
saying you can see steam. Yes, he's saying you can't see steam.
Hey, can we get back to solutions, not arguing, please?
All right, fine.
Pedantic, semantic, fucking whatever we're doing right now.
Potato,
Bullshit.
potato.
It's just backwards from everything I've ever known about steam and water vapor and shit. So.
And your ADHD just won't let it go?
I can't. Yeah.
For fuck's sakes.
It may be the superheated part that you're not
That's the
able to
only way he
communicate
could
on.
get me is the superheated steam. Yeah, that may be invisible. I don't know. Regular steam though is visible. I'm saying we can move on now. It's fine.
Did you see this refrigerator that I put in there? This direct drive. It only needs like 150 watts to run your big old chest refrigerator all
It's a
day
big
long.
solar panel, right? It's a pretty big panel.
I think it only needs like 500 watts total.
What's that, like the size of a car roof?
It's the size of one solar panel.
Yeah, like the roof of a car.
Yeah, I think most solar panels are like 6x3, 6x4 feet.
Okay.
Does it have a? Oh, go ahead.
No, go ahead.
It's got a DC compressor.
Thank you. That was my
variable.
question.
Yeah,
you're reading my mind. Thank you.
Yeah,
variable
that's
speed. Gotcha.
The variable speed. So it doesn't matter if the shade comes or not. It won't burn the motor up.
I was thinking go liquid, right? But then I was looking at what it would like what the cost would be for liquid. It'd just be so much more. I mean, you could pack more into a tank.
Oh, you're talking about hydrogen? Yeah, no, you got to go cryo, bro.
Yeah.
Is that what you're talking about?
Yeah, you got to get like temperatures of like fucking ridiculous temperatures to bring it down to a liquid state.
To cryo that, and there's losses in that too, by the way, when you're phase changing, and it's crazy because it has to stay negative 252 at all times, or you got problems. So I think that the happy ground is the middle ground, where it's the like the 300 bar, which is like 4,500 psi tanks, which are I haven't fully done my research in America. They're normalized in Europe. Like you can drive around with those big tanks, but I believe the DOT over here limits it to like 3,000 degrees. So they're only like 200 bar tanks over here. But if you're not taking them off your property, I would just go with those 300. You can get them for about $200 a tank, and I believe it's 500 liters worth of hydrogen. And then you put your hydrides inside of that, and it will increase the capacity. So 4,500 psi with hydrides, you get quite a bit of hydrogen in the tank.
Yeah, you're gonna need a fucking hefty tank for that though.
I sure would love to have enough H3O2 to experiment with.
4,500 psi.
I posted like 3 videos, man, of what superheated steam is. So talking to like engineer or power or anything that has to do with the boiler, and we're talking about steam. We're not talking about the steam that you can see. It's always superheated steam. We just never use the word superheated. It's what's the pressure?
Syrus, I talked Jeremy off the ledge.
You talked me
down. Now you're asking him to go back out onto that balcony on the top of that building.
I'm ready to get back into this right now.
All right, go ahead.
Also, you can see what it looks like. This is right there.
Does it look like
thumbnail?
water?
Just like look at it. No, you can't see it. The lights went on fire, match heads and shit. Like just simple.
You can see steam though.
Just heat it again.
I just want to know how they're making that. Is what I want to know.
I just have a second stage heater. Like all of the videos I posted, just top like little loop, hit it with a torch.
Yeah, I was trying to one up your Levelist, and I'm like, yeah, I'll go the liquid route, and I'll see what I can put together. And it just didn't work.
I mean, if you have the money, it'd be nice, but that's the same problem that all these hydrogen cars. Well, it's the same problem all these hydrogen cars, like they've been wanting to put hydrogen cars on the road for 20 years. The storage of the hydrogen is the major bugaboo. They don't have problems making the actual hydrogen. They're just, the problem is storing enough of that hydrogen on your car to make it worth your while to buy one to drive it around, you know? And
300 miles is dope.
Yeah, those are high pressure tanks. Those are the middle ground that I'm talking about. Those are 300 bar tanks.
300 miles to a tank is it's better than a lot of electric cars were doing when they came out. A lot of electric cars were only getting 100, 120, 150.
Like I said, the thing that there's a second version, the second model of that car actually surprises me. It's basically a luxury car. I'm surprised it doesn't say Lexus.
Well, that car went all electric. That's an electric car now. If you go to buy a 2025,
Mirai, Toyota Mirai. I posted them in the chat for you. I posted proof of those cars going for 4,000. Look. You never stay up on your. You're such a. You're not a chat. You're not a chat pro, bro. Just stay out of my chat from now on. All right.
I try to get in there, mix it up. Sometimes
you're banished from the chat. Don't ever go in my chat again, dude.
I mix it up. I mix it up with you guys every once in a while. You all got the point earlier with the flat horizon, though, right? On a globe, how the globe has a flat.
Something about a hula hoop. You said if I put a hula hoop on and then stand upside down, and I got two balls coming at my face, and then
do the hokey
my face, I'm gonna wonder how that thing got in my mouth.
No, I don't know what that was, but it sounded like the circus, which is what I feel like I'm in sometimes with you guys. But that's besides the point. The whole point of that is that.
Don't lower your voice. Don't lower your voice to me.
Everyone's sleeping. Everyone's sleeping here.
Let's get them riled up. Let's talk about some shit. Get riled up.
The whole point of that. All right, man. All right. The whole point was that they have a flat horizon on a globe. We have a flat horizon on flat Earth. It's very similar. There's not a lot of. It's just like the same thing almost. Oh, the horizon's below you, the ground. Oh, no shit. We're above the ground. It's below you on a flat Earth or a globe, like whatever.
Bro, that is crazy that steam can light fucking paper on fire. That is wild.
Oh, that's some crazy ass steam. Is it visible?
Yeah,
I'm
steam is visible.
I'm not getting in the middle of your whatever you guys are doing.
This is the invisible steam.
Steam is visible. It's visible.
They're saying this is invisible steam. No, Syrus is saying it's invisible steam.
I'm going to say it does not look visible to me on this video. No, it does not look visible.
CGI steam.
After it starts smoking, you could see what looks to be steam, but it's not steam.
What video, dude? I don't see it.
I posted like 3 of them at least. They're all pretty small, short videos.
Chat?
I reposted it.
Okay, thank you.
You have to go to YouTube though. You can't watch it in here.
There's another. There's that's in live stream chat.
I'm gonna say Syrus for the W. Jeremy with yet another L.
Well, it was on the superheated shit, but still water vapor's invisible though. That's just everyone's gonna tell you that. Water vapor is invisible. All right, Syrus? Or no? You were saying it was visible.
Right. That visible stuff you see, you got water droplets in there, and that's not considered steam. What's considered steam in engineering is this invisible shit that lights stuff on fire.
And you're saying water vapor is visible.
The steam, that what you call steam off of your soup or whatever, the suspended water droplets in there, right? That's not steam. And that's visible.
We're using the wrong nomenclature. Colloquially, we're using the word incorrectly.
Forget steam.
Yes.
Water vapor. Water vapor.
Water vapor
or invisible?
Should be 100% invisible.
Okay.
So if you see steam off of your cup of coffee because it's visible, well, it's not steam. It can't be.
What are you saying? What are you saying the thing is? What are you saying the stuff we see is?
They're little water droplets. They're actually suspended.
So not
in
water
the hot
vapor.
gas.
That's not water vapor.
There's vapor, and there's droplets that condensed vapor. When it touched the air, it started condensing.
Yeah, but just the stuff you see. Just the
like
stuff
your breath
you see
on a cold day.
Okay, but just the stuff you see. Just the visible parts. Obviously, that's not water vapor, right?
No, it's water droplets.
Okay, that's what I was saying. Steam.
There's vapor around it, though. Sure, but those are droplets.
Oh, yeah.
And we call that steam, right? But that's not. It's not steam. It's not correct.
I think it is correct. I don't know why that wouldn't be correct.
It's colloquial steam, like I said.
Yeah, but tiny water droplets. What else would you? Okay, what would you call it then?
But
What would you call the
just
stuff you
superheating
see?
steam.
Hold on, Pure.
Doesn't make sense.
Did you hear me to ask him a question? What would you call the stuff we see? Not colloquially.
Not what suspended condensed water droplets. Like we're not going to do that, right? We call it steam, but it is incorrect. But sure,
What
we
would
call
be
it
the correct?
steam.
What would be the correct thing to call that?
They're suspended water droplets.
That's just what you would call
Due
that,
to what?
suspended water droplets?
Due to dew point, like condensation, like, and you work out the dew point, and that will determine at what temperature you'll be able to see that, like your breath and all that shit. Just dew point temp. When you start having dew formation. Little tiny beads.
Dude, why is AI telling me steam is water vapor?
Bro, fuck AI, bro. Just go look up a thermodynamic book, just steam.
No, I'm
and
saying
just
they're
look in the
getting it wrong,
definition.
obviously. They're obviously getting it wrong, though.
It's, bro, I told you there's steam at, like, when you're talking like engineering steam or power plants or systems like that, they are talking about superheated steam almost always. 99.999% of the time, it is superheated steam that is invisible to the naked eye. You cannot see it because there's no suspended water droplets in it whatsoever. It is all water vapor that's 500 degrees Celsius. And they'll light shit on fire.
There's my notes on that cavitation heater. So would that work, Syrus, if you took that one of those big boy cavitation heater with like a 3 or 4 or 5 foot disc, Tesla turbine disc? Because that's essentially what the one I showed you is. It's it's a one disc Tesla turbine. You get that steam, and then from that machine, run it through a coil with another heater. With would that produce your super steam?
You saw before the nozzle, before the tap. There you go. There's your coil. Coil that line up, right, and put your external heater if you want, whatever, right there, right before far away from the valve, so it doesn't get too hot on the valve. But
would a direct running it to your solar panel with some of that wire, would that get hot enough, you think?
Well, this is where you gotta get yes. Yeah, the answer is yes and no, depending on, you're gonna have to do your mass flow rate. You need real numbers. Like you gotta know your mass flow rate. So how many watts would you need, essentially? Calculate that. You need to know the temperature of your steam, mass flow rate, and what you want to get it to. So you just essentially, if you want to increase it by 10 degrees Celsius, right, or whatever, 100, you do your math on that, and you size your panels accordingly. And of course, you size the panels to run the motor too. But absolutely, you can get superheated steam that way, dude. Even with a waste oil burner or something on that. As long as like your main drum can handle the pressures, because you're going to pressurize the whole system. And you're just going to exit the valve essentially as it's at the exit end of the turbine. So it's plumbed directly to the turbine. And that's where you just control it by the exit valve.
And then, so I guess I should have asked this follow-up question a lot earlier, but what are you going to do with that super duper heated steam?
Turbine. Plumb it into a turbine. It just, you're at more energy. It becomes more efficient at higher temps and pressures. That's why the boilers, they're running at ridiculous pressures, right? To, 300 bar, plus. So it's like 5,000 psi of a boiler, right? So that's where you get the efficiency, essentially, because you want the turbine to spin as fast as possible. More speed, more efficiency. So if you can get that turbine up to 100,000 RPM and better, okay, cool for a small turbine. Obviously, the large blade shit, absolutely not, right? But like a small 100 kilowatt turbine, yeah, as fast as possible. So Nikola Tesla's shit is efficient. Because his
Okay,
turbines.
but I'm
all
missing
in the
something though.
rhythms.
Let's go back to
Okay.
step one. Let's go back to step one. Is we're attempting to gain electricity from whatever invention we're going to make. So why wouldn't the electricity coming from those solar panels be sufficient for what we need in the first place? Why do we need to build another contraption after we have the solar panel and we already have the electricity? Do you understand my point?
You don't. Yeah, totally, you don't. I'm with you,
build.
man. I have solar panels myself, bro. Come on.
Okay.
Like, yeah, no, you don't.
I was just curious
Shit.
because I went down the Stirling engine rabbit hole. I went down the Tesla turbine rabbit hole, and I'm like, fuck, I want both of those things so fucking bad. And then I was like, why don't you just fucking load up on the panels? You build. You have twice as many panels as you actually need. Cover your ass on a cloudy day, and then just as the sun's in the air, just store as much of that shit as you can all day long. Bank it, and batteries have come down because I wanted the what are they, the nickel iron batteries, the original Edison batteries, the one that last forever. You can't overcharge them, and it doesn't matter if they're completely dead. You can bring them back to life. They're just indestructible batteries. But those are $25,000, $30,000 worth of batteries now. So I was like, all right, I'll just go with these new modern batteries. And then I was like, well, why not just do fucking hydrogen and turn that back into electricity when you need it? So
well, you gotta.
I was trying to overcomplicate the system too, but it just seems like that's the easiest way. Solar and hydrogen
Aren't complicated. Are complicated to build.
What is?
Aren't solar panels complicated mining and building? I know
no. I would just China. I would just get a couple pallets from China for 6,000. Call it a day.
Like overall, is it easy? You know, the price in China making. I'm thinking big picture. For building a turbine would be hard too, but it's metal instead of silicone diodes, or I don't even know. They're basically
your boy Tesla said his turbines were better than those these finned turbines anyway, Syrus.
I already know that, but so his shit comes in a weird time ago, man, because he was trying to make money at the time, so he did kind of advertise this as the end all be all solution, and it is for his apparatuses because you need the high frequency. So
I'm almost wondering,
that thing is.
Go ahead.
No, you're good. You're good. Go for it.
I'm starting to wonder why the fuck AC took over. Like, why do we need to convert and lose and get all these losses? Like, was he also? Don't get me wrong. If I invented the AC motor, I would fucking hang my dick everywhere and be like, yes, this is the best thing of all time. But in essence, like, instead of having one big major AC grid, why not everybody have their own personal DC grid? It just solves all the fucking problems, dude.
Yo, that's the way to do it if you're making the shit yourself on site. But if you're doing it like we do now, you got to use AC, obviously.
Yeah, you can do lighting.
Like the. Go ahead, bro.
I mean, DC lighting. A lot of stuff is run off DC cameras, all the shit we need. But then you step up for the appliances. They were doing that in places. But.
Well, I don't. What he was saying is like kind of retrofit your appliances with DC motors and just directly run it off the panel. Now, like I call that, which I do have plans like for like the greenhouse pumps and shit like that. Yeah, I call it standalone, little micro standalone system. But what he's talking about,
I call it rednecky. It's rednecky. I'll admit that it's very rednecky, but you just change your habits to getting your shit done during the day.
It's not rednecky, man. It's like you only spend 1/3 of the money, so I really fucking like it. The only thing is, I just kind of either have to have a universal motor or a DC motor. That's it. Because I love it. It's on switch when you need it. Just turn it on. It's directly coupled to the panels. And have some batteries, and a small inverter to run your electricity lighting at night. It's not much. A small, 48 volt, so 4 12-volt batteries, 100 amp hours each. That will definitely do you for just lighting, LED lighting strips at night. You're good.
And supplement the fridge supplement the fridge during the night, or maybe run a mini split. I have a dope ass like air conditioner like that runs off absolutely no watts at all. So
DC. How much was
Yeah.
that DC mini split? I didn't check the price on it on that 12,000 BTU.
I forget now. I'd have to look it up. Yeah, I want to say it was like
Twice as
like
much.
1,400. But no.
Okay,
They're just not popular. I want to say it was like $1,400. Let me double check.
Not bad, dude. Not bad. It's like it's within the same price.
Don't even
range.
need to run it to the panel. You don't need to run it to your power grid at all. You just run it off its own panels or its own solar panels.
That system is so clean, dude. All you gotta have in mind is fuses to protect the wires.
Yes. You need arresters. Like everything needs arresters for sure. And yes, you need a bunch of fuses. But like, have you seen how cheap you could pick up used DC motors? And they're fucking.
No,
they go for pennies.
I get them for free, dude. It's like no motors. 90 volt.
Yeah.
1800 watts. Yeah, dude. So that's what 2.5 horse, 750 watts to a horse, or 746, exact, whatever. So divide that out, 1800 watts, 90. Like that's awesome.
I'm only trying to take the load off of the your battery supply with like your 5 largest loads, right? I always forget all 5, but it's basically just your refrigerator's one of them, your washer and dryer's one of them, your water heater's one of them, your air conditioning's one of them, your heater's one of them. So if all 5 of those like are getting anywhere from 1/3 to a 2 horsepower motor, if you really wanted to amp up your washing machine or clothes washer, then all of the rest of your appliances in your house, your little blender or your lights on, that just takes peanuts, dude. It takes a trickle of electricity.
I like that. I like it. The storage is what really costs a lot of money.
Yeah, $1,500 for that EG4.
Nice. Okay.
Currently on back order. I bet it is.
More people are going off grid. That's where it's nice to have like a compressor that's like belt driven, so you can hook it up to your wind turbine or whatever, like your compressed air shit. Just running off your compressed air at night, whatever. Runs off a air motor, belt driven to the compressor.
Those Amish, there was like 6 sewing machines. He had those Amish women sewing up all that shit. He had four of those big old like 6 or 8 foot fan blades going inside that shop. He had like pneumatics are where it's at, dude. Air motors are dope.
Mm-hmm. It's sort of like the hydrogen, but like storing it in a pressurized gas minus the caloric energy, like density, like the energy density of like it's a fuel, right? Hydrogen is a fuel versus compressed air. It's all in the pressure, yeah. So storing energy slightly different way.
It seems to be a big, gigantic relationship between what we call solar cycles, 11-year solar cycles, and telluric currents.
I thought the solar cycle was 7 years.
11. There
11.
cycles within cycles. 11. Yeah, every 11 years.
Going back to the hydrogen, though, it takes a lot of energy to make hydrogen. In fact, I think it takes something like 50 kilowatts per kilo, and it only produces 35 kilowatts per kilo. So
takes 2 volts per cell is what it takes.
Yeah, the Faraday. You can look up the Michael Faraday. I think it's put the numbers on this shit.
The theoretical minute, it's 1.48 volts. Is 1.48 volts theoretically to break that molecule, but all the commercial hydrogen plants run 2 volts to those cells per cell. So it does not take a lot of energy to crack hydrogen.
Sure, it does. If you want to get 35 or 40 kilowatt hours out of a kilogram of something, and you want to use hydrogen, knock yourself out, you'll get it. But to get the hydrogen, you're going to need 50 kilowatts hours to crack 1 kilogram of hydrogen. That's
the idea was to run it off of solar panels.
Well,
So
you know
if
what?
you're during the
We
day,
don't know how much that is. How much per square meter we get out of a solar cell? That's almost nothing, right?
No, nothing I know. Yeah, it's not much, but because
Yeah, like-
they went down in price so much now, it's kind of like we're at this point where you can start playing around with these systems, and it's not too bad. Money
If you want to
wise.
let that thing, crack over a night, over a couple of days, you might be able to store that much hydrogen in a container, and then have fun with that.
Right. That's what he posted a video of a guy doing that. What was it? 60 days to fill up his tanks. Then he runs. How many days was it, Levelist? He runs off of that shit.
It was like 160 days worth of electricity for him.
Using a fuel cell, right, to convert it back to electricity. Or how's he?
He did not explain. He might be just running it into an old school. I think he was just running that into an old school generator. Like he's been around. Yeah, this guy's been around for like 20 years, and there has been quite a few advances. Like you could get way more efficient than that guy's setup. Like instead of those low pressure propane tanks, you could go high pressure. He said that his hydrogen generator is an alkaline. I would go anion based. I would go with an anion membrane, the newest school hydrogen generator, and then I would go with a fuel cell instead of running it in an old school like 3,000 watt Honda generator. So he had a bunch of losses. So you could be way more efficient than his. Is what I'm saying.
Well, your fuel cell is doing what? You have to have hydrogen as well, right?
Yeah, he's got the hydrogen stored up in bottles. Yeah.
Well, it still takes the energy to store it.
Yeah, but what's the efficiency of a fuel cell though? Because a gas motor, like 20% on a really good day. So it's like
60%.
60%.
All the hydrogen stored in those tanks, you'll get 60% energy back out of that through a fuel cell.
That's not bad. That's good. That's really good.
But that's not including what it takes to get the hydrogen.
Right. We're just talking about, I'm with you. Just stored hydrogen. Because if he's just burning it through a internal combustion engine, it's like, you can do way better than that.
Well, they make the internal combustion engine a lot more efficient when you're using hydrogen. It's still inefficient.
What's the efficiency? Yeah, what does it go up to? Like what, 25%? Does it even reach 25%?
No, in a diesel maybe it'll get to like 45, but not in the gas engine. They don't run the hydrogen that well. The diesel's where it's at.
Right.
I wonder if you run in a turbine. Because turbines get really good efficiency, like 40% or so, because of the speed. And they're always like multi-fueled, so I wonder if you can run a hydrogen turbine.
A hydrogen turbine?
Yeah. I don't know. I've never heard of one, so I need to Google it, man.
I mean, it's possible, I guess, but you still have to get the hydrogen.
You might be able to run it in a sealed. You could probably run it in a sealed system. You take 2 Tesla turbines, seal the whole system, heat one side of it and cool one side of it. Never let that hydrogen combust. It will just keep running. It's like not the Carnot cycle. I forget what it's called.
Yeah, that's a heat. You talk about
cryo.
It has to break into. It's going to break into Carnot. Your Carnot motor. You got to take the hydrogen. You burn it, and then it breaks into water. Now you got water. Then you got to take that water and split that into hydrogen and oxygen again. So that's where the energy comes. Electrolysis is one of the ways to do that. That still takes energy. So you can't have a perpetual motion device. Basically, is an analogy to that.
No, I think you came in a little bit late. We're trying to skip the batteries for energy storage, essentially.
Oh yeah,
we're trying to.
And the converters.
So we're talking
gravity battery. Would a gravity battery be better than
hydrogen is the battery? Yeah, you can look at hydrogen as being the battery. That's a good way to look at it, actually.
Yeah,
Would it?
because you
Is
can
this
come back 20
hydrogen
years
better than?
later. So there,
You
theoretically,
could come back to. Yeah, I'm saying would a gravity battery be better?
like a flywheel. What do you mean
No, like
gravity?
you raised.
What is that?
Much more efficient. Like I said, 50
You,
kilowatt hours to make a kilogram of hydrogen, and it only can produce 37 kilowatt hours.
Well, what are the
So
numbers on a
gravity
gravity
can
battery?
a gravity motor can gravity battery could recoup almost all of it, except for just whatever the friction losses are.
how do
So
you
I'm
build that?
saying
Like, what's it? Explain it. What's it?
you just
Well,
need
like
heavy
a.
weight.
Lift the weight up. Lift the weight up to top of your roof.
Okay, so well, we're going back to like water,
You spin a flywheel.
like water turbines. Your holding lake, your reservoirs, your battery.
Perfect.
You know,
Yep. Exactly.
you calculate it based on the height, whatever it is, rho GH or whatever the formula is.
So
MGH, no
you're saying
MGH, potential
the
energy.
gravity battery is better than this hydrogen business, Anik? About to take Levelist to school on this?
Because if you have a flywheel, for example, that's going to have some frictional losses which are far exceed a gravity battery, which is just water. It's just all it is above the height at which you're measuring the energy potential.
How much
You got
better is the
losses of
gravity battery? How much better is the gravity battery than the hydrogen? How much more efficient? And
Depends on how
probably
you,
what sounds like wildly
depends on
cheaper.
how are you going to pump it up there? You
depends on
got
what you're doing with
losses
it.
in your pump.
Cryophorus is what I was talking about, Cyrus. Check that video out right there.
All right.
He pulled a vacuum. Right, both of those bottles are halfway filled with water. One is heated to like 180 degrees. The other one is chilled to like 40 degrees. He opens the valve. He has it down to like, I'm bad with pressure numbers. It's like 29 point something degrees worth of
I
pressure.
remember this one.
And he opens the valve, and as long as you keep it heated and cooled, that will continue to run. So you stick a turbine in the middle of that, and it's not perpetual, but it's just very efficient power.
Right,
energy.
right.
Debunk that, Xanic. Yo, but for a
What
low
cycle
level,
does it run on?
Xanic said that.
Cryophorus.
Xanic said that the gravity battery is
I haven't
more
learned about
efficient
that
than
one.
it. Yo, can you guys hear me?
We're trying to ignore you.
Come on.
Go for it. Sorry.
Keep
I'm trying
talking,
to be
man.
quiet. I'm trying to be quiet because heads aren't sleeping here. But Xanic said the gravity battery is way more efficient than your stupid hydrogen.
Is it? Yeah. Good for
It probably
Zanny.
sounds cheaper too. It sounds like it's way cheaper of a system.
A gravity battery?
Yeah.
Pulling
Look,
shit
man.
up to the top of a tower during the day and then dropping it at night? You know how
Not
big,
cheaper,
you know,
man.
you know how big that tower would have to be?
You need like
You could
200
just use
feet,
a
bro,
heavy.
at least to get decent head pressure.
Hey, I got another one I want to talk to you about, Cyrus. So this guy took a it's basically let's call it like a 12-inch pipe, stainless steel pipe, 12 inches. He sends it 150 feet into the air, and then there's another pipe next to it on the other side, and he is putting compressed air into the bottom of one of those tanks, and that air, I'm going to fuck this up. Basically, by the time that air gets to the top of that first tower, it is expanded and heated itself all the way up, that it is a continuous loop. The left tank, the left tower is cold on the bottom of it, and then it's sending this hot heat all the way up through the system, and it's cycling itself down through, and it goes. It's a big old massive system, but it's basically perpetually running as long as the air is
Turbine pump.
Bro, it was so dope. And then I saw another one where it was a big tower. It was like a 12 diameter foot tower, and it goes up in the air like 50 feet. And they're doing the same exact thing that you think of it like 55-gallon drums, and you cut like a 1/3 of that drum off on the bottom side, and you send it up like a Ferris wheel. Like instead of a Ferris wheel going around in a circle, you crunch the Ferris wheel carts, the seats in a Ferris wheel, crunch them together in an oval, and you put the air on the one side of the cart, and it catches inside of that drum, and the air pulls that drum all the way up to the top of this cylinder, which is enclosed with water. So the air is pulling this conveyor belt of drums all the way around continuously, and then they hook a generator up to that. All it's running in is compressed air. Fucking dope.
That's interesting.
Where do they get the compressed air from?
You can get it from anywhere. You can get it from a windmill. You can get it from your own compressor. You can get it power the compressor from a solar power generator.
Would be better just to directly generate the energy from those primary sources rather than put it through this thing.
It could be, but I didn't go deep into that rabbit hole. I was just like, they're doing what with what?
So it's got to look at the source of the energy and then make your decision on if you're impressed or not with it, what you're actually doing with that compressed air. And all they're doing is that's whatever energy is in that compressed air based on the volume and the pressure that's under. That can do some amount of energy, and that energy is being used in turn this windmill. That's great. Is that useful work? Can you turn a generator with it? If those buckles were tied on an axis that was spinning around some coily wires and some magnets, could you make electricity? And if you could, it'd be better off probably just to use the compressed air to turn something directly than use this windmill or this Ferris wheel thing.
Levelist.
Yeah, I don't know what needs to look at it. No, all you, man. All you.
I just want to address Levelist. Are you aware of the nitinol generators?
Yeah, yes I am.
Excellent. That's all I needed to know. Good to meet you.
Yeah, I saw a couple of those working pretty well. I guess that stuff isn't all that expensive. Nitinol. It's just what is it? It's like aluminum and titanium.
Nickel and titanium alloy. Yeah. Well, I mean, they ask them, how long do you think it's going to take to be integrated? Because this was back, in the 70s? And,
yeah,
they were honest at the end of it. Let me see if I can find that. Would be really good. I'll DM it to you if nothing else. Oh, I found one with CBS, and he is asking them that question. Yeah, that's it. I'm going to just go ahead and put it in the live stream text, because it's quite telling here at the end.
All right, man. Yeah. I'm pretty sure I've seen it, but yeah, that's the kind of the sad fact is that I think that there's been multiple inventions that would greatly reduce our need for grid electricity and the price that we pay for that electricity.
Let's
I'm
hear
aware
'em.
of a couple more. I'm sorry, I was looking. I didn't hear what was asked.
Oh, I was making a comment that I want to see them. They would greatly increase our efficiencies of utilizing available power. Let's bring them out.
Okay.
What do you think's being hidden?
I posted up. Freaking, that goes so fast here. A link to one of the Rex research on the Gunnerman patents and the work they did.
The nitinol engine?
No, it's way above nitinol, dude.
There you go, truck.
Okay. And my wife has ordered me. Happy wife, happy life. I'll be back.
That's the thing, is like all those guys in like the 80s, 70s, 80s, and 90s, when they were all trying to come up with all these different motors and stuff, they were all trying to produce electricity, and like solar panels are just, they give them away for free now. So we have our electricity. We need to find something else that helps us. Is the guy that was powering his diesel with the French fry oil still in here?
Yeah, one day Levelist. I have to build my Steam setup. Steam is the way to go, man. And we're talking superheated Steam for Jeremy, not this water droplet stuff.
I wanted to share this. Did you see they came out with a new method to easily clean and prepare that fry oil for use in diesel? Have you seen how easy it is to do now?
I have not.
They just use gelatin, like basically Jello gelatin. It's so here's here's my notes. Ratio is 1 part. So like 1 liter of used oil, you would use 125 milliliters of water and 5 grams of gelatin, and you just melt it. You just melt it into it. So it only needs to go to like 100 degrees. I don't know where does jelly melt at. I think it's only like 100 degrees. So you melt the 5 grams in there, wait 24 hours, and then everything will drop to the bottom, and then you're done. Then you can dilute it if you want to. You could put some like real diesel in there or paraffin or whatever. But I thought that was fucking hilarious, because back in the day you used to have to mix a bunch of nasty chemicals together to get it to separate out. But they're just using jelly now.
What? Lye? What would they use?
No. Oh yeah. Back in the day, yeah.
I like sodium hydroxide. It's a great toxic chemical. I'm not a fan. I'm a big fan.
Fuck, I'll take
Cleans
Jello
everything,
packets, dude.
man.
Give me a 5 gallons of fry oil and a packet of Jello, and I'll fucking fire my diesel generator up for 3 days straight.
Yeah, Mr. Rudolph Diesel's engines another way to go, obviously. Multi-fuel engine.
I'm just going through all of my notes in my alternative energy channel in my server.
Yeah, diesel is another way to go, man. There's an old Mitsubishi I think they built a diesel engine that's got 40-to-1 compression. So that's what's up. It's badass.
Did they? That is rather
Yeah,
high.
which means it's going to be quite efficient because it's rather high. But it's got a short engine life, obviously, because of the high pressure. But because we'll have a brake mean effective pressure that's pretty fucking high, which is good. You get a lot of power out too, and efficiency in a small form factor. So I gotta look that one up, man. I remember when I was back in school, yeah, we talked about that one in class. Internal combustion engines. That Mitsubishi, yeah, I know it was Mitsubishi. 40-to-1 compression. White paper.
Yeah, I'm trying
We
to
should be able to find white paper on it.
Trying to find it right now.
Dude, I remember that.
Well, they got a bunch of different models, but it's not showing me the one that has the 40-to-1.
It's R&D. Look for like research engine, not actually put into production. They were just testing that. I mean, no keywords aren't. That's weird. Might have to go to a college library to look it up or some shit. Weird.
Well, I mean, if I can't find it used on eBay, there's no point to continue to look into it. But
Well, there is because you just make the combustion chamber smaller. There is. Wanted to look into because to get that compression, we'll just make a really small combustion chamber, or turbocharge it to death too. On top of that,
Mercedes has made a couple of higher compression diesel engines recently. You can get them used on eBay for like $1,500. So you can get them up to like 500 horses with a turbo.
cool.
Well, that's the other benefit of hydrogen, right? Once you actually have it in your tank, it's very, very simple to turn any old motor back into running that hydrogen off that for like a generator. It's not going to be terribly efficient, but it'll still get you some power.
Yeah. So I looked into like wood gas and all that. Man, I think that just going direct panel to motor, DC motor, and all that stuff is cool. And then for mega systems, steam, dude. I'm just not gonna fuck around. Just go with it one time. Yeah, diesel is another way to go, man. There's an old Mitsubishi. I think they built a diesel engine that's got 40-to-1 compression. So that's what's up. It's badass.
Did they? That is rather high.
Yeah, which means it's going to be quite efficient because it's rather high. But it's got a short engine life, obviously, because of the high pressure. But because we'll have a brake mean effective pressure that's pretty fucking high, which is good. You get a lot of power out too, and efficiency in a small form factor. So I gotta look that one up, man. I remember when I was back in school, yeah, we talked about that one in class. Internal combustion engines. That Mitsubishi, yeah, I know it was Mitsubishi. 40-to-1 compression. White paper. We should be able to find white paper on it.
Trying to find it right now. Well, they got a bunch of different models, but it's not showing me the one that has the 40-to-1.
It's R&D. Look for like research engine, not actually put into production. They were just testing that. I mean, no keywords aren't. That's weird. Might have to go to a college library to look it up or some shit. Weird.
Well, I mean, if I can't find it used on eBay, there's no point to continue to look into it.
But well, there is, because there's just to make the combustion chamber smaller. There is. Wanted to look into, because to get that compression, we'll just make a really small combustion chamber, or turbocharge it to death too. On top of that,
Mercedes has made a couple of higher compression diesel engines recently. You can get them used on eBay for like $1,500. So you can get them up to like 500 horses with the turbo.
Cool.
But that's the other benefit of hydrogen, right? Once you actually have it in your tank, it's very, very simple to turn any old motor back into running the hydrogen off that for like a generator. It's not going to be terribly efficient, but it'll still get you some power.
Yeah. So I looked into like wood gas and all that. Man, I think that just going direct panel to motor, DC motor, and all that stuff is cool. And then for mega systems, steam, dude, I'm just not gonna fuck around. Just go with it one time.
Yeah, you just match your panel, like you match the voltage on your panel to your motor. So you got open volts circuit at 40 per panel, and you got yourself a 3 horsepower DC motor running off 100. It wants 180, so you just go. I guess you just overpower it, give it 200, and let it run. Let it run all day long.
Well, if you need more like solar panel array, let's say just 100 watt blocks, you want more voltage, you connect them in series. Want more amps out of that parallel series connection. If you're gonna do like series and parallel series links, right? To get whatever, then just add parallel for amps. Yeah, for more. Get your whatever total demand is. And that's
I think most of those ones I was looking at, like your common 2 and 3 horsepower motors, which will run any machinery you want in your like your home shop. They wanted 180 volts at around like 10 amps.
Yeah, 1800 watts.
Then I was looking into drilling your own water well, and the prices for these like smaller water well drills, they're only like $1,200 in China now, dude. People want to charge like $20,000 to get a well on your property. Like,
yeah, how deep are you going though?
Like 200 feet, maybe. I think it was like 200 feet, 250 feet. So yeah, you got to get lucky if water can be.
Yeah, that's what I'm saying. This is where it's like, okay, you can drill it with like a boring drill, the one that spins. Yeah. You have major problems. What's the shaft diameter on that drill bit? The link, the coupling, like overall effective diameter.
I'll show you the cheap. This is the cheap.
At a certain length, it will twist like a noodle. At whatever depth you hit, there's whatever you gotta look it up. I don't know my numbers there, but let me just tell you, from torsion, you're just gonna twist that. At some point, it's just a spaghetti noodle. The motor is just gonna twist it off in the hole.
That's the cheap one I found. That one turned, I believe it was like 1.5 inch pipe. The actual drill bit was like 1.5 inch pipe, but the drill head, I believe, was like getting it out to 4 inches. That was the first one I found. There's another, like the next step up, where it's like an actual frame built for it, because it's too heavy for you to lift all day long, and you just like pneumatically, basically, the drill goes all the way down, and then you jack the drill back up, put your next pipe in, drill it down, lift it up. It's like $1,200. That one right there is only like $600 or $700. The cheapie, I just put it in the chat.
Yeah, I have doubts in my head. It's only like 1.5 inches or whatever. But I don't know if it can go 200 feet with that.
Yeah, the videos. Feet, yeah, the videos on YouTube. They were on some soft ground with no rock is what they were drilled into. So.
So how much power are you producing a day on one of these? Like, what do you imagine in Levelist? What size system? I'm just trying to imagine. What's the ideal amount of power?
For me, it's about 20 kilowatts an hour, which is, I guess it depends on what part of the world you live in. But I think I read the average American household is using like 10 kilowatts a day. So in 1 hour, you'd be able to produce twice the amount of your entire day's worth of energy in 1 hour. I'm going to go big on the solar panel portion of it, because I want to use as much of that as I can and try to store as much of it as I can.
And then you're gonna you still go on the hydrogen route? You're gonna convert it?
I will do that secondarily. I'm gonna go just solar panel and batteries like traditional. But basically, I want to do as little AC as possible. Like I want only maybe like 4 or 5 AC outlets. I want all the rest of it to be DC. I don't know if that's actually feasible but basically, I just want like a monster car electrical system, or an RV system, basically. Why wouldn't that work for like a house or like a small home? I don't understand why it wouldn't work.
What? Copper cost. It's not, it wouldn't work. It works. But the weight, so if you do like standalone, each device has got a panel, array of panels nearby, then it's not that bad. You're not.
Yeah,
running wires all the way across your house to a main panel. So
yeah, for a 12 volt system, I agree with you. But if we're running it at 48, that's much smaller wire. So is the cost of wire really a drawback?
Yeah, you got to calculate the voltage drop for 48 volts. I mean, it's still less than, especially for DC, it just drops significantly.
Like I said earlier, I'm predicting they're going to go to 96. I predict in the next 10 years there's going to be common that there's 96 volt systems everywhere.
Well, it would lower the amount of material of conductor necessary, unless we move away from that.
And all of your appliances. Well, no. Well, here in America, you guys are all 220 everywhere else in the world, but we're at 110. So if you're producing 96 volts, like your motor is almost can be directly plugged straight into it, even on AC.
What do you mean, even on AC? You still need to convert it from DC to AC, right?
Well, I'm saying I want as little AC products in my system. I want everything to run off DC.
Yeah. And that's the running camper vans and stuff. I've always sort of deferred generally to the AC because I already have to apply AC. And you can just go buy secondhand fridges. I don't know under what circumstances you might be acquiring such goods. If you want to buy brand new and you can afford it, go for it. DC, you can get the specialty products, but they're always more expensive than the AC stuff. So, anyway, someone else want to jump in?
I'm sold, man. I'm sold on the idea. I think it's fucking brilliant.
Okay. What about have you guys looked into any of this composting power plants, methane production stuff? Levelist, I'm surprised you.
Yes.
Like, why wouldn't you consider?
I have. I went. No, I went down. I did all my research. I wasn't planning on like using it for a fuel cell. Like in my mind, I was going to get two benefits out of running a methane.
Than the AC stuff. So, anyway, someone else want to jump in?
I'm sold, man. I'm sold on the idea. I think it's fucking brilliant.
Okay. What about have you guys looked into any of this composting power plants, methane production stuff? Levelist, I'm surprised you. Yes. Like, why wouldn't you consider?
I have. I went. No, I went down. I did all my research. I wasn't planning on like using it for a fuel cell. Like in my mind, I was going to get two benefits out of running a methane biogas digester. I was going to get anaerobic compost for my garden, my plants. And then I was going to, well, I guess three things, because I was going to do sewage, right? Human sewage, getting rid of anything that's going to rot on your property. You throw it inside there, and so you get disposal of sewage. You get compost for your plants. I guess for the human sewage, it would be for trees only, not for anything you're going to eat. And then the third thing would be the gas that's produced. But I'd never thought to, because you can turn methane into electricity as well. There's methane fuel cells, but I was just thinking that the hydrogen would do all of those things for me as well, but easier. And of course, the other thing would be to like actually cook with it, cook and heat with the methane. But I can do that with the hydrogen. So
I was looking up the numbers because I was thinking about something about the size of a shipping container, just a 20-footer, and then orientated on its side, long ways up, so it's a tall chamber. I was looking at 420. It was saying something like, I mean, these are just AI figures, so whatever. I haven't done too many hard sort of sums on it, but it's saying about 400 kilowatts of power per day per shipping container. So off the chart, and it was saying it was like you'd be able to run about 30 households, 40 households off that one, and it'd be so simple to set up. You wouldn't need to worry about capturing it because you just like it's friggin' biodiesel, man. You just vapor it, like you run a pipe right up into the air, so you don't have to smell it and all that stuff. You just anything you're not using just gets wasted. And then if you run a couple of pipes through it, right, like a thermal exchange, you can use that heat to run some sort of heating, because you would need to thermally regulate it inside, because I've seen these things catch on fire, right? Compost units catch on fire. So you need a heat exchange or something to be able to turn it up and turn it down to get the optimal methane production. So you need to do a bit of plumbing work there.
So they're
crazy, like it's advantages, man. And you're already dealing with gas. You don't need to store it. It runs day and night, no batteries. And then I was also looking at it. Most municipal buses and garbage, I don't know what it's like over there, but over here anyway, all your municipal buses are running on this methane gas basically already. All of your garbage truck disposals are all running on it. So you've already got engines and machines and all this industry rigged, ready to roll, like with a methane thing. So I don't know, I thought that was kind of cool.
Well, what do you mean you don't have to store it though?
You just wouldn't need to store it. Like I consider the idea of compressing the gas with all the valves, regulators, upkeep of the compressor and whatnot. It's very burdensome. I mean, you could do it if you need to, but very burdensome. You'd be better off actually just up-regulating and down-regulating the methane production through the heat exchange. And then if you get a little bit too much, basically you just you waste it off. It just goes up into the air. You don't need to worry about sort of storing it.
Do you have access to that much compostable material? Like if you're going to make that much energy, you're going to have to put a lot of sewage or food scraps, leaves. Like there's going to be a lot of stuff needing to be, because they need to be fed every single day. You need to take most of the time they're not built straight up like that. They're actually built in long bladders, like they're like 30-foot long bladders, and you feed one, like you could just think of it like a long elephant. You feed the elephant on one side, and then he shits out the other side. But the stuff that he's shitting has all been broken down anaerobically, right? So it's all sanitary and clean now. And all of the water, like you can water your plants with the water that's coming out, and you could feed all of the solids still coming out for compost as well. And you collect the gas. I don't understand what you mean by letting it run out if you don't want it. Like my whole purpose would be to collect it. I want to store it and then turn it back into energy whenever I choose to. So I don't know. We got our wires crossed here. For maybe we're not talking about the same thing. Are you talking about a biogas digester? I sent you that thing. I saw this. It's a steel mold for like rebuilding your own in-ground biogas digester. You set this steel mold up, and then you pour all the concrete into that mold. And then, it's like a 2-day process. You have to build the lower part first, and then you build the upper part, and it collects it in the ground. Oh, and then the other thing I wanted to say about, so you need to keep putting organic material. You have to feed it every single day, and then it needs to stay in a very finicky range temperature-wise for those microbes to stay alive and to keep pumping out the methane, to keep converting all that shit into methane. And it's just, I'm not saying it's impossible. Like you could run some PEX tubing around, like if you're in a cold area. This is more applicable to cold areas where much of America is, everywhere in the north is cold. It's hard to run those biogas digesters. You could run some PEX tubing and give it some, artificial heat in the wintertime to keep those processes going. But it's just like it's a little more finicky. I want to fart around with it, but it's not on the top of my list of things to do anymore. I think the hydrogen would just be easier for what I would use it.
Well, I mean, you could. Okay, so the wastage off thing, first of all, why waste it off is because you don't want to deal with the storage problem. Even with your sort of system, right, like your hydrogen production, you're either going to, like at some point, you're going to produce too much. I mean, you always want an overcapacity, right? So you're going to produce too much. You want to store it up. I mean, look, maybe you can sell it. Maybe, I don't know, whatever you're thinking at that point. But at some point, either you're going to have to turn it off because you're going to have too much stored, right? Like you're never going to need 100 tons.
Yeah, you're right. 100%.
So that's what I'm thinking about with the dealing of the wastage off portion of it. And then as far as, I don't know what these systems are. I mean, you're looking at a sort of pre-bought system, like for the, what was that fancy term it used?
Biogas digester.
Biogas digester. Okay.
That's what they get marketed as to the normal people. Yeah.
Yeah. I mean, that's kind of cool that it can go horizontally like that. I was just thinking of turning the shipping container up vertically.
It might work for you. Size. You're in a very normalized climate down there in Australia, right? It doesn't get too cold, or it doesn't always stay pretty warm down there.
Yeah. That is something to be dealt with. It usually gets pretty hot, so it's the biggest deal we got to deal with.
I don't think there's as many problems on the hot side as there is on the cold side. So
that's why I was thinking you need because I'm imagining these biodigesters don't have any thermal regulation internally. I don't know how you would even sort of thermally regulate it, but if you just run a heat, just imagine I'm sticking with the shipping container for my ease of imagination, but just a container with, just run some copper pipes back and forward into a heat exchange. And then if you need more gas, you turn up the temperature and you get more bioactivity. And if you want to slow it down, you can basically just run those pipes as a radiator at that point and just get the temperature down inside to below sort of bioactive. I don't know what the figure is. What is it? Is the ideal sort of somewhere around the 45, 50 mark? If you can get the temperature down internally to 30 degrees, you can just reduce the methane production that way.
Yeah, but
then that way you can slow down the use. Like if you haven't got enough foliage to chuck in there,
do you have a bunch of stuff? You have access either a bunch of leaves, or are you near a farm where you can collect horse manure? Or?
Yeah, I mean, there's a couple of horses here, but we burn off a whole bunch of foliage every sort of once a week or once every 2 weeks, depending on how much is being produced. I'm not sure if it'll reach quite the capacities that I'm thinking with the shipping container size. Apparently, it was saying something massive, like a cubic meter per day or something. I don't know if we produce that on 1 acre. I
tagged you in the chat. This is like what gets marketed to your average American looking at this sort of thing. That's just like maybe, I don't know, 2 or 3 meters long by 2 meters wide. And it has sandbags sitting on top. So the gas is permanently pressurized, basically. And it's marketed, though, just to run like stoves. Either you take that and you compress it into a propane tank, or you take that and you run it through your stove and you make your coffee and your eggs on that every day.
So that'd be that's so easy.
I agree.
I think that's, I don't know, man. It's just making more sense to me.
You can run that like in the
Run it
summertime,
sun.
like seasonally. People can run that seasonally here. Like you just run it for the spring, summer, and fall, and then let it go in the winter.
That's the advantage. That, like, I mean, you were seemingly implying that these things don't work too well in the cold climates. But I'm just imagining, dude, like something as big with as much thermal mass as a shipping container, right? 'Cause you need to get the mass up. Your biggest issue actually during the summer is making sure it doesn't catch on fire internally or start smoldering. But in the cold, as long as you've got enough thermal insulation, right, on the outside of that shipping container, or maybe like insulated on the internals of it, you can like it's all the heat exchange is primarily all the thermal exchange is happening through that heat exchange. It's completely regulated by that flow of water. And you could probably, I wonder if you could even actually make it automatically flow, such that as the water heats up internally, it'll sort of create a pressure and just naturally cycle itself.
Well, the other thing about a shipping container is it needs to be pressurized, right? All that is under more than atmospheric pressures, right? It's probably sitting at, I don't know, 7, 8, 12, 14 more PSI like, than atmosphere. So how are you going to pressurize your shipping container?
Why does it need to be pressurized? To create flow?
Because the majority of that is water, right? So that thing I showed you in the chat right there, it's filled up like more than halfway with water. So like 1/3 of it is air. The methane is going to displace it and is going to start pressurizing. It's going to turn the solids into gases, which is going to overinflate the internals on that. You need to regulate that gas coming off. The top of the bottom is where the magic happens. The gas will then be stored in that thing sitting on top of it. And then there's sandbags sitting on top of that. So everything needs to be pressurized because we're dealing with gases. We're trying to collect the methane, which is a lighter than air gas, and that's the usable aspect, the thing we can store or put to work. So everything needs to be sealed.
Is the gas collection on those little devices, is that at the top of the unit?
Yeah, you can use any kind of bladder. I've seen people use beach balls. You could use those big old like tractor inner tubes. You could use an IBC tote. You can use anything. But it's slow going, right? You have to feed it every day because it needs new material every day. That would be pretty small scale. Like I wouldn't know how you guys have the same size propane bottles as we do, right? They're like 15-pound, 20-pound propane bottles.
Yeah.
So I don't know how long that thing would take to fill and like a pressurized. I'm guessing that thing would probably take 2 weeks, a week, maybe. I don't know.
I was imagining a month or something. We could probably
maybe, right,
to work it out, but that's a fair bit. Just for that small.
Whereas the hydrogen generator that I'm talking about will make in the range of like 7 to 10 liters of hydrogen a minute. So it would only take me like a couple hours to completely fill a welding tank pressurized full of hydrogen.
Is this using the solar panel setup with the HHO generator?
No, yeah, well, you can call it HHO because it is just a modified version of HHO, yes. But it's just a monster, like not those ones that everybody was farting around with trying to put in their cars. It would be like 16 of those in a row in a stack, all daisy chained together with membranes in between. So we're separating the hydrogen from the oxygen so that we're not, because that's the dangerous stuff. That those HHOs are actually Brown's gas. That's when hydrogen is actually dangerous, when there is oxygen involved. So you need to design the generator to separate the hydrogen from the oxygen, so you have usable hydrogen.
Yeah, I've seen that. But you're saying that, like, what is it? I mean, when I said 420 kilowatts per day is the amount that's produced by a shipping container-sized compost unit, right? And just imagine how small that is. Your biggest issue is actually, as you said, trying to get enough material to feed it. But as long as you can slow it down and turn it up, like you're sweet, I think. But like, what are you talking about? Like, how much power are you creating with this HHO? Like, is this over Unity or something? I'm assuming there's.
No, it's just electrolysis. No, you could take a battery, take a 9-volt battery, and put it inside of a water. You're creating hydrogen. You're creating hydrogen and oxygen. But no, it's not over Unity. I'm just collecting.
No, but like, how much power are you getting from the solar? Like, how big is your solar panel array?
Well, you have to go huge on the solar to
yeah,
account for the burn off on the conversion to hydrogen. Because to run everything, you're gonna have a massive drain, right? So you're gonna have to go. I don't know. I'd probably say like a high percentage more than what you actually need during the day, just so you can run during the night.
I put a pallet, like a pallet worth of modern solar panels are going to be in the neighborhood anywhere from like 350 watts to the big boys are 500 watts. The best deals are on solar panels between 350 and 400 watts. Roughly 33 panels come on a pallet, and if you get the 400 watts, that's going to be like 15 kilowatts worth of power. So every single hour you'll be producing in a perfect situation, you'll get 15 kilowatts worth of power an hour with one pallet full of solar panels. I'm probably going to go with like 2 pallets worth of panels.
Holy shit, dude!
Yeah, but it's only $4,000, bro.
No,
it's only $4,000.
I think we've got a 9,000 kilowatt top of the shed.
Yeah, I'm thinking like 20 to 25 kilowatts.
That's good size, man. That's about the right
huge.
size you need. 20 kilowatts or so. It's pretty good. Even for conventional solar.
Exactly. That's what they were recommending
exactly
like in the 90s. They were recommending those size power in all through like the 80s and 90s and early 2000s. That's what they were recommending everybody in America. now they try to, the modern solar, they're just trying to fuck you. Like, they don't even give you batteries. They just want you hooked up to the grid.
Yep.
But did you see the prices on, like, I put a couple price sheets on the pallets worth of solar panels, how cheap you can get them? No, this doesn't.
I might,
this doesn't
I might have to get them new, man. Because locally,
yeah, that's
here,
what
I
I'm
can get
showing.
275 watt for about, gotta buy a shitload of them for about $50, but they're used panel. They're in great shape. And that comes out to the same as the brand new ones here that you posted. So it's like, I'll go brand new because efficiency, right? You know, a little bit of losses. I don't know how many years they've been used for. 10 years or so, they start, degrading.
Yeah, but even in 20 years, they're still going to hold like 85% of their efficiency.
Yep.
Maybe 80%.
As long as it's the price, though, right? I'm just, price per watt. So if I could get it for 17 cents a watt new, hopefully shipped, or a little bit more for shipping, cool. 20 cents a watt new. Well, that's what I can buy it here locally used for. If I buy a shitload of them they got the 275, and I've seen some like 450 watt or 475 watt panels. That was a better deal, I think. But it's the same price getting it used now as brand new if you get a pallet. So might as well just get a fucking pallet.
It's kind of interesting the dynamics.
You can buy newer tech, yeah. What's up?
I don't know, it's kind of funny to me. What am I trying to do? I'm like, I want to produce the gas and then create the energy, or turn it into electricity, and you're like, oh, no, we're going to take the electricity and we're going to turn it into gas. Okay.
Yeah, because the solar is the cheap part of the equation. Like, look in there. So those are 350 watt panels. That pallet has 33 panels. That's 11.5 kilowatts worth of energy every single hour.
$2,000, right?
Situation. $2,000. That doesn't include shipping. Solar is the key to unlocking all the other shit. Like, that's my point.
So how come we didn't talk about the 20% efficiency cap?
350 watts.
Yeah, that's what I said. 350 times 33 is 11.5 kilowatts.
Okay, so every hour you could make, or every 3 hours.
Kilowatts an hour, sir.
I know what kilowatt hour is.
It's joule per second.
You have hold on. You have 5 hours. You could make 1 kilogram of hydrogen.
Yes.
Oh, okay.
No, you mean 5 hours worth of sun?
5 hours worth of sun. If those things were working, if they were actually producing 350 watts per panel, and you have 11 kilowatts, you said, then you have 5 hours, and you could get 1 kilogram of hydrogen.
You don't know what generator I'm making. How do you tell me what I'm going to get?
That's the maximum you can possibly get with all the inefficiencies of converting or creating hydrogen. You need to have.
I'm looking to get 10 while it's working, while it's functioning from the sun. I'm going to get 10 liters a minute worth of hydrogen.
No, sorry.
Yes.
But that's he used volume and used mass, and the conversion hydrogen is really light. So a kilogram of hydrogen makes a lot of liters. So we need to. You guys are in speaking two different languages here. Okay, let's look up the specs. Let's look at the specs of the hydrogen generator.
How much a liter of hydrogen weighs?
Yeah. Danny's going to say use batteries. That's what
I know. I need do the conversion.
Use batteries.
No, it's.
But do you understand, Rick? Do you see I tagged you in there? You see how cheap it is to get the power? Like, the electricity is no longer the problem.
No,
the key to having. Sorry, Zanuck, I was in the middle of a conversation. The key to having all this excess power, especially you, because I know the solar irradiation down there is excellent as well, is trying to figure out where to put all this free fucking energy coming from the sun every single day into something that you can store. So the methane is the low hanging fruit. I would prefer to do the methane for the compost action. That anaerobic compost is amazing. But
I got some numbers here.
To turn that gas back into power again, we don't need the power. We don't need the electricity from the gas because we got solar all day long. But you can do the same thing. You can store methane. Go ahead.
You get 2 weeks worth of overcast bloody weather. I don't know. I'd be concerned at that point.
That's why I would oversize the system. I would do 2 pallets worth. I would get 20,000 or 25,000.
You made kind of a point that you get 20 liters per hour. It doesn't really matter. Like you said, the volume is not the question here. It's really how much mass you get out of it, how much mass of helium you get or hydrogen you get. And you're talking about 50 kilowatt hours from to make 1 kilo of hydrogen. 1 kilo, that's it. So you're not going to, and it's a little bit, it's about 3 or 4 times as, productive of energy as gasoline would be. You can think about, okay, so if I need to have what does a 25-gallon tank of gas weigh? Well, if I make it out of hydrogen, I really only need, a fifth of that, or whatever, close to a quarter of that. But still, you're talking about days of charging to get that much hydrogen to be able to fill up a gas tank.
So the other thing I don't know, man. If this is a competition of ideas, which I'm sort of taking as a bit, but you've got whole municipal bus systems and garbage trucks already running on natural gas, methane, ready to roll. You just buy a couple of those doozies up in the aftermarket. you tie a couple of alternators to them, and you're producing power instantly. You're off to the races. Augment it with a little bit of battery on the side, just so you don't have to have it running constantly. I think the other trick is also with solar. I mean, I don't think it's necessarily the cost of the panels. It's the cost of rigging it all up and getting it installed. You plan on doing that a bunch of yourself?
Yeah,
Getting it to the cylinders. That's going to be the bitch. That's going to be such an expensive. That's where I imagine the most the price is going to come from. Going from the point to solar to the tank and getting it in the tank.
Was that the compression point, you mean?
Yeah. Yeah, because you got to filtrate like all the liquids, any type of liquid. You don't want that sitting in your tank. Just the array or cascade, whatever you want to call it, for all the tanks. You're going to need like 5,000 psi tanks, right? For like 300 to 400. I forget what the fucking ratio is, but whatever. You need like 5,000 psi tanks, and you'll probably want multiple of those. And then you want like the little like some type of like pressure readout panel that way you can like regulate everything. You can see the temperatures, but you know what I mean. You're gonna want it all that information at the ready, so that's gonna be a little price point. But it's doable. It's definitely doable. And the more you're fueling, like the bigger you expand it, the more beneficial it would be. I guess what I'm trying to say. Like if you upscale it, you're gonna get more benefit. Like the more things you're powering, I would say, the more you're gonna save money.
Dude, wiring up a solar system is like the easiest shit ever, man. So you got plus and minus.
Exactly. It's
Don't fuck
simple,
it up.
dude.
Don't fuck it up.
It's dead ass simple, dude. The hardest part is mounting them, like finding the proper angle and mount. Like, yeah, that's
shit.
But you can build your own brackets, and it's not hard.
Just buy them, bro. Just buy a fucking box of brackets, dude.
It's not rocket surgery.
Yeah, that part, I think it's a breeze, but getting the gas to where it needs to be, I have no idea. Like just trying to guess that, I'm thinking like tens of thousands.
I can show you. I can show you a smaller version. Let me try to find a video for you. These I forget what they're called. It's basically like an H tank. It's like two cylinders vertically.
Oh, get a T, at least a T.
You want the oxygen separated from the hydrogen.
Yeah, bleed it.
But you want it like the thing you want to do is save both. Like a lot of people just bleed their oxygen off into the atmosphere. But if you store both your almost 100% pure oxygen and your almost 100% pure hydrogen, when you go to turn it back into electricity with your fuel cell, you get 30% more efficiency if you're pouring pure oxygen into that fuel cell as opposed to atmospheric. Does that make sense?
Oh, so you're gonna but you don't need much for that, do you?
I don't know. I haven't fucked around with fuel cells a whole lot. I was looking into the generator side of it.
All right, yeah, if you're gonna utilize it, then it's a no-brainer to at least save some before you bleed it. But I think you just produce way more oxygen than you'd ever need.
I think you use that oxygen, that condensed oxygen, in the combustion process, though. So
you got to pressurize the oxygen.
Perfect formula.
You got to pressurize the oxygen. That's a whole other set of problems for you on that particular logic. But I understand what you're saying. And it is true. It'd be better than the semi-permeable membrane of a fuel cell to extract the oxygen in the process. But how are you going to? What do you do with that oxygen? The hydrogen is being used. The oxygen would not be.
You'd have to bleed some. But yeah, that's what he says. You need another compression line.
Yeah,
that would
get yourself a medical O2 concentrator, and then you get the pump, the used medical pump that I think can pump it up to 2,000 psi, and there is your 97% oxygen setup and better.
The pump takes energy to pressurize it to 2,000.
Yeah, well, we got 25 kilowatts of solar panels.
How much power do you want? Yeah.
500 watts to a pump is not a big
kilowatts
deal.
an hour.
Leave it to Zanuck to discount the last 5 hours of conversation and come in and just try to figure it all out.
Levelist.
You're talking. You already agreed that it probably makes it 20 or 30% more efficient through the fuel cell process, but you'd lose 10x that trying to pump and save the oxygen to be able to save the 30%. You'd have 300 or 400% losses to get the 30% gain. It doesn't add up in your logic there. That's all I'm saying.
I've got too much energy. I need to figure out what to do with it.
But we got to run some math. We really got to run efficiency numbers and all that versus compressed air. Like, what if you buy the most efficient pump head you can get and do it that way? Because that's where your heat losses are at, right there, and compressing the air, so you can turn your, DC to DC or AC then to the pump or whatever. Friction losses. Yeah, friction turns into heat. Yeah, it's friction.
No, but or the compressing the air turns into heat too. That's also creating, but that's not the majority of the loss. The loss is the fact that you have to actually compress the air, and that is actually doing work. Compressing air, doubling the atmosphere in a container is equally calculable for energy, and it's a lot more than any ever would have in the fuel cell efficiency gains.
Okay, I'm not talking about the fuel cell myself. I'm saying like if we spend $5,000 on our 25 kilowatt panel array. Now I don't want to spend 10 grand on batteries. Is there a better system? That's what we're in the storage. We're talking about the storage of the excess energy. Because even when you got your batteries, when they're topped off, right, you're using just a little bit, right? Because you don't want to really dive into your batteries that much. So
during the day, especially, maybe at night you do, but not during the day.
You don't want to even at night. I think the voltage like delta. Oh, go ahead.
I was just going to say, I think the value for storing hydrogen is in that calculation of 55 or 50 kilowatt hours per kilogram. So I think that's in there. Adding oxygen to that would be a whole other, leap up.
Yeah, I haven't looked
into
that yet.
If you're only doing like a small scale of oxygen, it's not going to be a big deal. Just getting like they're saying like one little tank of oxygen at 2,000 psi. That's nothing. But if you're trying to harness both like equally, like all parts of oxygen, then yeah, that's going to be fucking expensive. But if you just set it to get out like your 2,000 and then bleed the rest, that's not bad at all. Send me a video. You got like a video or anything on like the system that does it?
Yeah, and I'm looking for it right now. It's not.
Right, cool.
I didn't like bookmark it or anything. So let me try to look for it right now.
Yeah, because I've only seen industrial setups, and those aren't affordable. Yeah, I'm looking at numbers. It says like 25 liters, 25 kilowatt an hour a day. You get about 200 bar. So 200 bar, you can get cheaper cylinders too, if that's all you're gonna. Well, no, because then it'd be what 2 days for 400 bars, and that's like one T tank at like a 5,000 psi T tank. I think it would cover four. It's like 450 maybe max, somewhere around that. So like 2 days.
Yeah, I get confused because it said 1 kilogram of hydrogen is 12,000 liters of hydrogen.
Wait.
But it's all dependent on the pressure. It's like you can just shove more hydrogen into those higher pressure tanks.
No, that's not what it is.
Yeah, it's
no. It doesn't matter how much volume it is. It matters how much. 1 kilogram. It could be,
I said pressure, not volume.
Or 1 liter. You put it all in 1 liter if you want to, but in the pressure, it's not going to matter. I mean, it's still relative. How are you going to use the hydrogen if it's spread out? That's where entropy comes in. If you guys flat earthers always like to talk about entropy, yeah, this energy is spread out. If the hydrogen, it's very difficult to utilize it. But if it's in a gallon container or 2 gallon container, and you have a kilo in there, then that's it's going to be under whatever pressure it is to create that kind of density.
What? I don't even know what you're saying.
You're saying that
a kilo of hydrogen in a 5-gallon bucket.
Yeah, you need some pressure to do that. Just like you need a kilo for kilo oxygen. I had a 10-pound bottle of nitrous oxide, which is basically air, as far as all practical purposes are concerned here. And that took $50-$60 for them to do that. And I got it around I think it was around 1,500 psi. I think it was 2,000 psi. I can't remember what it was. Something in that range. So that's what, and it put in a little bottle that was like about a couple gallons, maybe 3-gallon bottle. And I had 10 pounds in there. So that's about 4 kilos in a bottle. You can do that with hydrogen too.
And when you pressurize it, you can fit more in.
Yeah. I could make 20 pounds if I wanted to get 4,000. It's all gas law, right? You double the pressure and you have double the density.
Right. So what's the problem?
Well, there's no gains for doing that. There's no advantages for having more in a
smaller storage footprint. What do you mean there's no gains for doing that?
Well, how much? Like you said, how much storage you need. Why do you need to be so small? And then when you get into higher pressure, then you got into safety issues and structural concerns of the containers. And hydrogen is not really an easy thing to contain safely when you start getting into higher pressure because it is risk of failure.
It's just as safe as every other gas, man. That's just gaslighting.
That's not No,
it's safe if you use the right type of container. The containers don't just randomly blow up and dumb shit like that. No, it's safe.
They're all pressure related. You start going higher pressures and you get more risk for them to fail. If they fail, it's catastrophic. It's not like any other gas. It's combustible. Oxygen is inert. Nitrogen is inert.
That's not how it works. It's not you go higher pressure, there's more risk to fail. That's not even true.
The risk is directly proportional to the pressure. Absolutely.
Not on the fail rate.
Sure.
You could fail on fucking 10 psi just like you could on 100 psi. It's all on how it's built. If the system's overpressurized, it's going to fail. If it's not overpressurized, it's not going to fail.
But you're talking about putting much higher pressures into these containers that could make them fail, and they're more likely if they have failure.
No, you get containers rated for like 5,000 fucking.
That's what they're built for. What the fuck are you talking about, Danny?
That's like saying you can't transport welding cylinders because it's too dangerous. Like what?
Well,
they have a whole entire industry built around this, and these places don't blow up, dude.
The containers blow up a lot. They have containers that actually do blow up in crashes for sure.
No, yeah, in crashes.
Don't listen to this guy, man.
Like someone lit up a bomb. Like come on,
oxygen is an inert gas.
It is an inert gas. Oxygen is
oxygen. It is not an inert gas, bro.
It is an inert gas. It is.
Oxygen. Okay, you want to Google it and prove me wrong?
It's not flammable. It's not flammable. It reacts.
No,
it increases
flame. I didn't say it was flammable, but it's not inert at all. It's very reactive.
Can react. Yes, it can react with other gases, or it can combine with.
How's it inert? If it reacts,
it's not. It's not a noble gas.
I meant flammable. Sorry, it's not explosive.
Okay. Yeah, I'm with you on that. It lowers kindling temperature. It's not inert.
It's highly explosive.
Yeah, that stuff is awesome. Love it.
Well, hydrogen?
Yes.
Yeah,
that's not that unsafe. If you
buy it from the welding supply,
have you heard
buy
of
it from the welding supply store.
Yeah, you can. It's like buying gasoline. It's like buying any other acetylene. It's buying any of these gases that are actually explosive. Oxygen is not. Those gases are. That's why you had the Hindenburg.
Way cheaper. Fuck acetylene. Way cheaper than acetylene, by the way.
What maybe, but that's if you already got buy hydrogen. We already know what it takes to make hydrogen. How much energy it takes.
It's really cheap compared to acetylene, bro. There's a reason why I bought it.
I know that, but you don't power cars with acetylene.
No, I'm just talking for like in shop use.
Yeah, but I
mean, easy storage. Just
bottles.
Buy the steel tank and all the right.
Hey, Syrus, you'll appreciate that. Check out. I linked you in the chat. Check out that badass Stirling. That's one of the best Stirling engines I've ever seen, dude.
Oh, I love Stirlings.
It's a monster. You know those low temperature ones, the ones you put on your coffee cup and it runs at
LTD.
Like
that's the one I built.
It's a monster.
I built that type.
This is a big boy version of it, dude. It's so dumb.
Is this the old? I've seen a monster LTD run off solar. This dude, it's an old school video. And a gigantic. Bro is huge.
This is a new company. He's trying to sell
LTD is the low temperature differential. Oh, okay, cool.
It's a 10-month-old video. I just found this recently.
Nice. See, it's contraption.
And I'm not finding these hydrogen videos as easy as I was the other day. I wonder.
Yeah, that's the point I'm worried about is the cost. I don't even like where could you buy it from? Where can you buy all these components from?
You can get them off.
Just
you can
milk you.
You know
what I mean? Because it's like an industry specific thing.
Yeah. You have to make contact. You have to send a bunch of emails. You're right. They don't sell these like on the shelves to the public. You have to try to get a hold of one if you want to buy one.
Yeah, you could go to like a Air Gas or Total Weld. I don't know what you have in where you're at, but you could just go to like a gas supplier, and you could probably hook up through their supplier, and maybe I don't. Yeah, that'd be tough. That'd be tough because I'm trying to think how you get it cheaper. Like maybe if you got it through their supplier, maybe they could get a better deal than you could. If you deal with like, say it's like Total.
Depends on how much.
Not good.
If you're buying a lot, they'll give you a good deal from your gas supplier, like your welding supplier or whatever. I do not like air gas. I hate air gas somewhere else besides air gas. Pretty expensive.
Why don't you like air gas?
They're expensive, dude. They're argon. Yeah. They charge an arm and a leg for their argon. Like, come on, man. You can get it elsewhere for like almost half the price. It's like, nah, don't like them.
Yeah, they are expensive, but man, they deliver. They show up.
They're everywhere.
We got Total Welding around where I'm from, and the fucking drivers sometimes they just don't even show up.
I guess took over our local, our local supplier. They bought them out and took it over.
Yeah, they're good at that.
They charge too much for their cylinders. I don't know, man. I'm just not a fan. Not a fan.
Yeah, the only thing I like them for, well, the reason I like them is because I've never seen them late on a delivery for like small shops. Like Total Welding, sometimes, man, they just fucking blow you off if they're too busy. They'll give you the runaround and shit. I'm like, yeah, we'll come by today with a bottle. Well, like 2 bottles. And they never do. They'll show up like a couple days later, maybe the next day. It's like, you can't yell at the driver. But they're a lot cheaper, so yeah, I get what you mean.
Yeah, I'm just home gamer, little hobby shop. So yeah, I just take the bottle there myself and exchange it.
Anybody interested in raising sheep? I put like 40 or 50 hours worth of research into raising sheep. Have all my notes right here.
Yeah, I got a buddy that does pigs. Well, sort of buddy. I haven't seen him in years, but he did pigs. Fucking, he retired from at what was he, like 32 when he retired, and just did his pig farm. Retired from the trade. He worked the trade to save up enough money to like establish the farm properly, get everything he needed for equipment, and then he just retired. And now he lives off the pig farm.
Yeah, sheep are a little easier on your farm. Sheep will improve your plant biology, everything around your farm, where pigs are attempting to destroy everything on your property. So
why not goats? Then you can rent the goats out to people, and they take them for a couple weeks, clean their fields up, and you take them back.
We know why you like goats.
You got a sick.
I think sheep taste better than goats, and more docile and easier to care for. Goats will try to get out of anything you put them in, and sheep are just a little bit more like, okay, we'll sit here with one wire, one electrical hot wire wrapping around us. There's plenty of grass. We'll just stay right here. Goats will be like, fuck you, we're going over there. We're going to climb that tree over there.
But eat all
yeah,
weed.
They'd be able to defend themselves better. A goat, I think it'd defend itself better than a sheep. A sheep is just toast.
Maybe the ram, but all the female goats ain't defending themselves from nothing. Not even a coyote.
Say, man, I've met some hellacious billy goats in my day.
Don't get me wrong. If you were buying a completely untouched piece of property, there's nothing there. No one has ever touched that land before. I agree with Xanax. Goats would be the proper animal to go in there, because they would just completely mow all of your fields or all of your land for you. All the trees would be up to 5-6 feet high off the ground at that point, and then all of that material that they ate, they would give it back to you by shitting all over your land, ruminates, and then starting the microbiome, giving that back to you so you can start planting in that land. That's the quickest way to jumpstart a new piece of property is with goats, in my opinion. And then as soon as they've done their work, as soon as they've cleared that land for you, I think you turn it into meat, and then you put sheep on that land. But that's just my opinion.
Oh, we have some awesome food growing in our property.
Spoken like a true farmer right there.
But plant life. And fortunately for us, where we're located, we have hogs that are considered a nuisance, and we have year-round permission to blast them away and eat them and use every bit of it.
How's that wild hog taste? I've never had feral.
You don't want them upset. You want just a peaceful, loving death, just like everything you want to pray over.
What do they taste like?
You don't want to run them. You don't want to.
Want that adrenaline in the blood?
Oh my God, yeah. It makes a huge difference. Also, whoever's preparing it is being prepared properly. It's freaking delicious, man. I mean, like my brother, he's got basically a little meat processing plant, and make ground venison, ground hog, sausages, and jerkies, and yeah, just man, yeah. When it's done right, man, it's freaking delicious. You won't want to go back to what is it, McDonald's or any crap like that ever again. It's like those of us that are accustomed to raw milk, trying to go back to homogenized stuff they call milk on the shelf. Yeah, no comparison.
Hey, Pure Rigger, I can't find exactly what I'm looking for, but this will kind of give you this. I think he's getting around 4 liters a minute with this little. I would make one that's like 4 to 5 times as big as he made there. I think he has 12-inch by 12-inch plates. So he minus his gasket, so he's got like 11 by 11 worth there. And I think he's in the 4 to 5. I would try to shoot for like 10.
All right.
And then did you watch that that other one that's kind of like the old school? This hydrogen guy's been around forever. Did you see that video? I would just recommend watching all these on like 2x speed. It's not like you're gonna. I'll drop it. I'll drop the other one too.
Dude, now you got me fired up for my Stirling project again. I don't want to think about it, but I do.
I think the Tesla turbine would be easier to build than a like a 10 kilowatt Tesla turbine would be easier to build than a 10 kilowatt Stirling.
The problem is I have engines here. I have spare engines. The idea, which this one I've never built. I've built it. Most likely this is going to fail. Okay, a super complex project that's going to fail. I'm going to just make a gigantic LTD, probably multi-cylinder. So the idea, I got a couple engines. I thought of one is a V6, one is an inline 6. So on the V6, right? I have to go and depending, I might have to use a V8 because I need 90-degree timing, like 90-degree offset on the crank between 2 pistons, essentially. Okay, between 2 cylinders. And if I got that, one of them is hot, one of them is cold, right? So the cylinder head is, of course, it's custom stainless steel, all welded up, because that's going to be in a hot fire, just straight up into the red coals, yeah? And just run basic cooling and just a gasket there and whatever. And the hot air gets pumped to the other cylinder, the working cylinder, displacement cylinder that does the work, right? And I've never built it, like I've never did that, but the idea is you can. And I might be a little bit easier for me if I use 2 engines, and that's where I might go, because I have more flexibility between like the crank angle relationship, because that's important.
Did you see that? Did you listen to that guy with that video I sent you? That model is not 90. It's not 90 degree. There's not a 90-degree phase angle. He's using a non-sinusoidal crankshaft. It's like 135 to 45.
For R&D, I would do an LTD with where I can change the angles on the fly for research and development. Because yes, the phase angle nobody really knows. Like you got to experiment with your design until you figure out.
He said like there are a multitude of reasons why your Stirling engine will run less than optimal, but through extensive research, he basically said the 3 biggest ones, the 3 biggest red flags is your phase angles. So he chooses to run his at 135 over 45. And then he's using, are you familiar with the term sub-regenerator? He's using sub-regenerators in there.
I know what a regen is, yeah. So what's a sub-regenerator?
It's like stacked, like, those, it's basically like wire mesh. You know those like grills when you're frying something? That's a regen.
Yeah, I know
he has like, so he's using, it's like layers of them. It's like a density gradient. Yes, thicker, closer to the hot side, and they get farther apart to the cold side. Okay, so he's using sub-regenerators, and then he's using the absolute lowest amount of dead space inside there. So he doesn't show the inside of that motor. I'm thinking I'm thinking that his displacer is his regenerator, and his regenerator is a sub-regenerator.
There are designs that way where the piston is displacer too.
Yeah, I think that's what he's doing.
I'm sorry. The displacer is the regen too. My bad. It's built in. You can't.
So that was interesting as fuck.
It is, and also if you run it on nitrogen, again, bump up the efficiency. There's
hydrogen
a bunch of shit.
Hydrogen even more. Hydrogen's the best known. I don't know. I've never read anything.
Yeah, watch out for leaks. Because it does run in a fire. So, I mean, yeah, it's fine.
Yeah, but you can bury the whole setup, dude. That's the thing. You can make like just like a storage unit underground. Just bury your tank setups and just run line, to like the generator area, and then have the generator area underground too, and vented, and then go to like some type of panel.
Okay, I'll tell you like what I want to build. Let's say you got a 55-gallon drum, a burn barrel. We'll make one out of concrete with a custom top for it, whatever. But the idea, like I was thinking, if I I can turn the V6 a hot V, hot side of the V and a cold side of the V, right? It just sits right there, man. It gets directly heated. In like so the cylinder head would poke inside of the barrel essentially, and then there's an exhaust plume up top or whatever. But so it's kind of an outdoorsy thing because you can just feed, whatever combustible material into the barrel, whatever it is. And I'm just trying to get like 50 horses out of it. Not that bad, like 40,000 watts, 40 kilowatts.
People have been working on hydrogen vehicles for quite a while now, and some better outcomes than others.
Stirlings are cool because it's external combustion, so that is the cool bit. That is the cool bit about it. Run it off of whatever solar heat or whatever. You just need a temperature differential between the hot side and the cold side. Yeah, I know my just retrofitting an old engine or a couple of them is hard. I think it's more work. I'm better off just machining the thing from scratch. The idea is I would like a large contraption. I know those work, and the problem, like with my old primitive small ass model, it was like only 6 inches in diameter on a displacer. But the other one, the big piston displacer, I think is a small piston on that type.
This is what I have.
It just had no torque. Well, I had some, of course, torque, but I got some speed out of it, which means I needed a longer, bigger crank. You want more torque, bigger crank, right? Which means it's a longer stroke on the displacer. So, I can go with smaller piston, or smaller cylinder and piston, and longer crank arm. Get the same displacement out of the displacer. Get more torque.
Notes on sub-regenerator. Sub-regenerator porosity cone. Expansion to the cold side and contracting to the hot side is can be thought of as a gradient. The study shows that power output and engine efficiency increase when porosity is reduced from 90% at the cooler interface to 70% at the heater interface. Lanthanum nickel alloy was the material they liked the best. Higher work, these are findings significantly improve Stirling engines recovery, sustainable and efficient. Yeah, I had never heard of those before that.
Oh, in the video I posted, this guy shares his hydrogen generator method on this vehicle that he had no problems with.
Oh, is that the Corvette? I think I've seen that.
Yeah,
That is the Bob Lazar.
Whatever. I don't care who he is and whatever, but I do appreciate the knowledge he shared with this back in the day because it really opened my eyes, along with a lot of other people.
That's the Area 51 guy.
Element 115 or whatever.
Yeah.
Well,
that car is dope though. He's got 4 of those tanks in the back, and what did he say? He could do like 300-400 miles in that car.
That's cool.
It was on up there, man. Depending on how fast he wanted to go, it was all up to him. Yeah.
That might only cost like $20, $25 from the store to fill that up to 2,000 psi each. Like there were smaller tanks. I think all 4 of those together, it's probably the same volume of the bottle that I have.
Were you here when I was talking about putting metal nitrides inside of those hydrogen tanks to increase storage?
Yeah. Interesting. I need to look into that.
Yeah. So, it's called graphite carbon nitride. You can remove that hydrogen from that bottle without applying, because the original metal hydrides, like the titaniums and the aluminum, the nano aluminum that they're putting in there, you had to heat that tank up to like 400 degrees to get the hydrogen to come out of it, to turn it, to put it into the fuel cell. So they're trying to come up with a method to be able to remove that hydrogen at much lower temperatures. And graphitic carbon nitride can do it essentially at room temperature, like I think less than 100 degrees Fahrenheit. Which, by the way, to make it's expensive as hell to buy it, but it's urea You just bake the shit out of. You can make it in a microwave, or you can make it in a kiln. You just put urea. We all know what urea is, and some sugar, and it turns into this black graphitic powder, and it has a multitude of uses. Like I saw where these guys were taking that carbon and they were putting it in concrete, and they were increasing the compressive strength of concrete by like 2 or 3 times, something like that. It was going to like 10,000 psi, adding very, very minimal amounts of this graphitic carbonic nitride. It was amazing. And that gave me a myriad of ideas to do with that, because I love cement.
Oh, that is cool.
My dad was a cement salesman. I'm always thinking of like to build shit out of cement first.
Making my own concrete here, man. The cheap way. You shovel the sand and gravel beneath your feet. Add 10% cement. There you go. Cheap, weak ass concrete. You can build shit out of.
Well, the nice thing about that is you don't even need to go buy all this fancy aggregate. You could almost use the soil in your own backyard, add polymer, and add this graphitic carbonic nitride to your own soil, and you could probably get somewhere close to like a commercial grade concrete. Is what I was thinking.
I don't buy aggregate. I just shovel the sand and aggregate beneath my feet. It's got perfect aggregate in there. Fine aggregate. You know, I know you need different sizes, but that's okay.
So
good enough for how cheap it is.
Building your own house literally out of your own soil that will last for a very, very long time sound very appealing to me as well.
Okay. Levelist, if I recall correctly, the discussion earlier when I came in was AC and DC, and I think someone was trying to point out the fact that AC is much better for the transmission long distance, and I think you were speaking of actually local
microgrids
harnessing. Yeah, local harnessing, and not long distance transmission. Correct?
Yeah, that's what I would use it for. Yes.
Yeah. Okay. Yeah, that way you don't have the loss because it's right there.
Well, like I said earlier, like, and if you're implementing as many DC motors into your system, you're also reducing all the costs for extra battery storage. You're increasing your conversion rates, and you're reducing all of your costs for all of your like solar charge controllers as well. Which that's probably the part that goes before the battery.
Yeah, I worked on these systems back in the day, man. Like, it was a cutting edge tech, right? And the inverters, the power banks, we call them batteries, that's normal folk. But anyway, all the like fine tuned software that come out after we had to go through and manually, figure out and trial and error. Any research or development, you're going to have that. But yeah, I mean, it's advanced from that point. That's available to public now. Like back in the 70s when I think his name was Watts come up with luminoid, which is a material that revolutionized solar industry.
Isn't that the stuff that makes hydrogen as well? Doesn't it react with water and it makes like perfect hydrogen? And you can't find it anymore?
It has so many different, we went through so many different applications because of the properties, the emissivity, absorbency, reflectivity, all these different properties, and how to incorporate into photovoltaics to preventing the sun from heating a structure. Really, really interesting developments. And fortunately, I signed no NDA, so I can speak of what I know. Yeah.
Am I thinking of the same stuff though? Isn't that like yeah, it was made for like low temperature aluminum welding, but they found out if you do something with water, it makes like perfect hydrogen. I might be thinking of a different
Yes.
model.
No, I don't know what I know about what you're talking about. Yeah, that guy. that made that aluminum solder compound. That
Isn't that
also
what it was called?
marketed it as he also marketed it as firecrackers, liquid liquid firecrackers. You throw it in water, you get firecrackers, hydrogen.
Yeah, check him out. Make sure his name is Watts. We might be speaking to someone different, but we might be speaking to one and the same. Because, like I said, all the different applications that we were learning about.
Yeah, dude, I'm looking at the numbers for this and what you're gonna put out for hydrogen. Dude, I go with like at least 400 bar. It just looks. The numbers look so good. This guy in the video is talking about in what 8 hours he put out 550 liters.
Is that the British guy? The British guy or the American guy?
The do-it-yourself science guy.
I forgot what I gave you. Let me see.
He's probably British.
Does he have an accent or no? Because the guy that has the accent, he's trying to sell an all-in-one system. He has a really small hydrogen generator. He runs it off of only like 600 or 800 watts worth of solar panel. He has an onboard compressor. That compressor, he repressurizes the same tank twice. I think that's how he does it. He gets it to 200 bar, which is like 300 psi, and then he repressurizes it again, and it gets it to 300 bar, 4,500 psi. And he's trying to sell that all-in-one unit for about $12,000. But it's on the small side, in my opinion. Not that I'm a hydrogen snob or anything, but
he probably cut your deal if you wanted like some custom thing.
Is that the one you were talking about, or was it the guy talking about using solar power and just leaving his car plugged in overnight to get his tanks recharged?
Yeah, so that's the first guy. That's the American guy. That's the guy I found first. This British guy, I found him. He's a really good educator. If you go through his channel, you could learn all about hydrogen storage, and he sells access. He himself has emailed tons of hydrogen generator commercial producers of hydrogen generators because they don't advertise to the public. And so he has this price list of all these different generators from all the different countries. So he's kind of like a little gatekeeper. You have to pay to get access to it. But I'm not going to fault the man for trying to make $1.
So you're going to figure out how Stanley Myers did it, and then just tell us all.
No, so I don't. I'm starting to rethink. So I was totally on board with. I don't want to call it fraud, but like knowing his system was a wet cell. That was a wet cell system. He wasn't separating hydrogen from oxygen.
Neither were the Gunnermans.
But the numbers that you were getting, he was breaking Faraday's law by like 200x or some bullshit.
Yeah, because I read his notes. I read his minutes. Like I read when he made a plea. Like he went in front of NASA, and he was basically on his knees groveling. Like, look, like I don't understand why you guys aren't putting this technology in everything. Like, I can only take it this far. He was like begging NASA to like pick up his research. And I was like all on board with that guy. He was like an American patriot. He was trying to do what he thought was right. But then after like looking more into it, I'm like, maybe he was just over exaggerated claims. I don't want to call him a fraud. It looked like he was actually doing it, but it just, I don't think that was the answer to all of our problems.
How far did you get with it? I mean, do you recognize that he wasn't the one that came up with it?
No. All that stuff was a little before my time. All that stuff in like the 80s, I was just a kid, like, and so I'm like trying to piece it all together 30 years post hoc, you know. So
he was basically the spokesperson, right? It was his brother. And a lot of people question because what has been released, right? There's a lot of literature and diagrams, and talk about using lasers, noble gases, etc. And a buddy of mine was looking at it. He says, "This doesn't make any sense." I said, "Why is that?" He said, "Because he's using lasers." He said, "If anything, you need to remove heat." I said, "You mean you've never heard of laser cooling?" He's like, "What?" And then but anyway, I mean, I've got questions on it. I'm not sold 100%.
I'm very new to this. I'm not going to proclaim myself an expert at all, but I have read verifiable scientific reports stating that magnets increase hydrogen production. I think it might be more on the side of it basically blasts those bubbles off the surface of the plates faster so that more hydrogen can be produced after that. And then I've also read reports where it was talking about certain frequencies. Like they think that water has a certain frequency, and if we blast that resonance into that water, it might blow apart at much easier and more efficient values. So I'm thinking everything else is frequency and magnets. So why the fuck wouldn't hydrogen production be, have benefits from frequency and magnets? But I'm not claiming I know how to do that.
Well, yeah, you don't have to claim to know how. It's like you don't have to claim to know how your digestive system works to eat a fucking plate of supper. If it works, it works. And, that's like whenever I go into a project R&D, with a goal of mine, whoever I'm working with, I let them know. I said, I have no rules. Only rules is, does it work or not? And if so, how well, let's evaluate it. If it's no better than what we have already, then, it's not worthy.
I agree. That sounds like it'll work.
Well,
I haven't.
Oh, go ahead.
I haven't given up on Myers yet, even though he does lie on his pens. But I think there's more to it because he says it's a resonant cell. But then in his pen, he's got and he highlights it. He calls it choking diode. Like if you have a diode in your circuit, well, it's not resonant, bro. Well, we won't allow the current to flow back the other way. It's not a resonant circuit because he's got a choking diode in his diagram. But he calls it in the text a resonant circuit, so it's not. So I think he was doing something maybe that he wasn't telling us.
Yeah, or like I said, it was a wet cell, and then like those pipes inside of a pipe. Doesn't that not seem like enough surface area to get the numbers he was claiming?
No. Ravi. Remember, Ravi was the only guy that came close, and he disappeared. Right? I think Indian government scooped him up, and he ended up going there. I believe that was the last trace of him. It's quite famous in the HHO forums. The Ravi cell video from like the early 2000s. That this Indian fella, his cell pumped out the hydroxy just like the HHO, like Stanley Myers, bro. And that's it. We never hear Ravi ever again, and that's interesting. Because it was like a 1-to-1 replica of Myers, and there's plenty of those, but nobody was able to make it produce that much hydrogen. Ravi did, and I think there's a paper by a Dutch engineer. He's got on his own website, right? That he thinks he might have cracked how it actually works. Because if you ever experimented with this shit, like I have, something called I think they call it like seasoning, or there's a different term for it. What it is you have to wait until this white oxide layer, which is an insulator, develops on your plates on your cell. Once you have the oxide layer, your cell produces a lot more hydrogen. It's like gas, hydrogen, and oxygen. It's quite noticeable, right?
Yeah, what they call it, like conditioning the plates.
Conditioning. Conditioning, yes, sir. So that engineer, he was during a time where like even Ken Wheeler were all reading the same website about the ether and what Dollard was saying, and he thought about it, and he was saying because that's an insulating layer. So the key might be in the electret, this like thin layer of oxide that's actually electrically insulating, but because of it, something like a capacitor, right? Like an electret is similar to a magnet. A magnet produces a magnetic field around it, and an electret would produce a static field permanently around it. Like when you bring an electret close to your arm, it'll make the hair stand up, right? It'll just always have that electrostatic field tension from it. I believe it was that term was coined by Sir Oliver Heaviside.
I'm gonna guess J.J. Thompson. That's what my guess was.
No, Heaviside, if I'm not mistaken. It's an electret. So developing that electret layer, essentially an insulating layer, oxide layer, on that cell might hold the key to everything. That we're kind of thinking about it backwards, because he did it without current, right? Stanley Myers, very low current, and that is actually the key. You need the cells to not be that conductive. You need to go the opposite route of adding sodium hydroxide or some kind of hydroxide or salt to conduct more current. Like that's the wrong way. The idea is to put distilled and get minimum current flow as possible, but maximize. We don't know. Nobody was able to do that besides Ravi. It's interesting, or at least apparently on camera.
That is the newest. When you look into literature, the newest commercially available electrolyzers are doing that. They're using basically 1%. They're trying to get to 0%. What is that? Sodium potassium? What is the electrolyte? KOH is what they call it.
Either KOH.
They're trying to get it down to 0, but they're at 1%. They can get commercial grade hydrogen at only 1% electrolyte now. That's called AEM, anion exchange membrane electrolysis. But I put this thing I put in the chat right here. This Reg Pie. It's an Asian lady. I'm assuming the guy. It's like a white guy making his wife do it on camera, or something like that. But when you look for like hydrogen generators on YouTube, they're exceedingly shadow banned. You will be able to find HHO for days. And this is essentially an HHO generator, but on steroids. Like it's the Cadillac version where it automatically separates your oxygen from your hydrogen, so you're not making Brown's gas. So this is like a very, very, very cheap, crude, rudimentary version of a hydrogen electrolyzer that anybody can make. I mean, it's just stainless steel plates and some bolts and some plexiglass. And the only like key feature is the membranes that you put in between the cells, and then you have to cut the gaskets themselves in a certain order to get the separate oxygen and hydrogen to flow in the right direction to come out of those holes. But I've scoured YouTube for days. There's literally only like 2 or 3 of these types of videos that make a real hydrogen generator, as opposed to a gajillion HHO versions. Like they just bury this information. That was very, very difficult to find.
You can do the HHO and separate your cathode and anode, like just the gases off of each one and trap it. But it's again, you're into the electrolysis, and we're trying to run around it.
I don't see what was wrong with that space cadet guy. His technique for harvesting the hydrogen and refueling his car seemed like the simplest, easiest way. The one I posted up there earlier, as far as having hydrogen practically applicable in your vehicle and available at low cost. That's just my take on it. That's all. It seemed quite simple. Makes a lot of sense. Yeah, I mean, he's talking about some of your stuff, Levelist, as far as using solar and whatnot to power it.
Yeah, it's free. The sun is free.
Yo, Levelist, do you have the book by, I believe it's Patrick J. Kelly? It's just an encyclopedia of all the free energy stuff, like 3,000 pages. Not sure what the latest edition is.
I had that website. That website is no longer accessible through archive.org, by the way. But I think I know what you're talking about, where you go to the website and it's just completely jam-packed with PDF files. Yeah.
Well, you can download it in a PDF format. I have several older ones.
I have some of them, yeah.
Yeah, okay.
I didn't go through all of them.
So you would go under hydrogen, boom, there you go. Oh, there's so much shit. Like it's unbelievable.
What's his name? I'll try to look for my little PDF stash.
Should be Pat Kelly, last name. Should be Patrick J. Kelly. Think so.
Yeah, yes, I do. PJ Kelly. Yeah, vehicle systems.
Yeah,
okay. Moving pulse systems, overview. Yeah. Water propelled internal combustion. I've got wow, I got all of them, I guess.
You learn about like Bob's cell and all that. There's different HHO contraptions that are not conventional. Non-Stanley Meyer. And his brother, by the way, I know about his brother. I believe he fled to Canada, started a company named Exogen. Funny, they sell a square cell.
If I recall correctly,
extreme numbers.
Yep.
Yeah. I know that solid state, straight from the ether, like that one Tesla vehicle that he had, Nikola Tesla, Pierce Arrow stuff. Story. How the story goes that in the glove box he had like a cigar box with like 12 vacuum tubes in it or something like that, and he took it up to 80 miles an hour and he said, "Now we have power," and it ran no batteries, directly, no antennas either, straight off this foam somehow.
It's on my to-do list to figure out what the fuck those vacuum tubes. Seems like every single one of those contraptions around that era, all were using vacuum tubes, and I don't even know what the fuck they are. I have no idea what they are, what they do. Like
evacuated.
Oh.
Go ahead.
I'm sorry, go you first, because I'm gonna you go. It's a long story.
Well, anyway, each depends on how each individual tube is an individual, so you'd have to experiment with each one. Especially back then, I'm sure it was way more that way. But to get the tone, the tune, the resonance that you're looking for. So if at certain frequencies there's broadcasting a certain data and energy level, right? However, it was working for them. he was able to receive whatever this was from whatever source, from my perspective, if, the tale is true.
If the tale is true. But like the other tubes, like Mr. Gray and his motor, of course, what's his name? T.H. Murray. There's a bunch of people where, again, tubes are at the center of this, and they're non-conventional vacuum tubes whatsoever. But they all have a common mode of operation, including Stanley Myers. And this is the side of me that believes that he actually did something, but he totally lied about it in the patent. Because according to the theory, this was the way. It takes us back to Tesla and his discovery of these waves, these other non-AC, non-DC electricity, and you get into the world of impulse DC. And all these inventions after that, they all have one thing in common, including Mr. Myers, is he used an impulse, what he calls an impulse train, which is just a capacitor charging. But they were all DC, impulse DC, tube-based devices. The one theory was like about Stanley Myers is, well, his thing is not resonant whatsoever, but it acts as a water capacitor, right? And he just charges it up, like he puts the tension with impulse DC, and it just splits it up due to impulse, like frequency, not necessarily the power that's going into it, very little amperage. So it's not alternating the power that he's feeding it. And the magic is in the circuitry, apparently, right? So this is where we go back to Tesla. Now we backtrack and need to understand what Tesla is doing. Because Mr. Edwin Gray and his motor, like he would just cold electricity. This guy would demonstrate the stuff on stage, like break the circuit with like his hand and doesn't electrocute. Like, don't get electrocuted. You complete the circuit. It's weird. Tesla demonstrated similar effects on stage too.
You're talking about Gerard?
So, and
Gerard?
There's a couple of motors. There's a couple of dudes I always get on. There's the End Machine guy. Okay, it's not him. There's Edwin Gray or something like that. Edwin Gray motor. And you'll find publications in the newspaper about him. The Edwin Gray, I want to say. You'll find it in that Patrick J. Kelly book. Actually, like, there's no way you're not going to find it. I don't know what category you would classify it under. There was like the End Machine. That one is an interesting one too. There's a couple of these electrical contraptions.
You think any of them? You think so? When I went to that website, I was like, obviously, not every one of these quote inventions in here is legitimate. Like this seems like a like a red herring. But I have a feeling that the magnetic motors, like they seem to get like the least amount of attention. I have a feeling those would be on the easier side to make, especially with neodymiums. Like because those guys. Correct me if I'm wrong. I don't know what year neodymiums were made, but those guys weren't even using neodymiums in those. So like,
there were several of these guys, man. Like the Turkish guy recently, and of course we don't know what happened after that. He demoed that thing. You can see the video. He just goes in a bit like with a crank device. He just kind of flicks it over with a little key from the back, and that thing just whirls. It's like, oh goodness. Okay, I think display was in Netherlands. That's the only convincing one that I've seen, and he displayed the internals to somebody at some point, and of course we never hear of it after that. But that was the most recent, very convincing magnet motor, which I do not believe that you can get work out of magnets. But again, I was indoctrinated, so I don't know how in the world these guys got work out of a fully magnetic motor. But if he's not a fraud, that he figured it out. That one Turkish guy, his motor got torque, buddy, torque. Like it's like, oh shit, that's real horsepower. Isn't that a toy?
Well, I think it has to do with
that fan that he had on it. All right.
I think it has to do with like setting them up at the right angles, right? Because there's, I forget his name. I read his book.
Like the V gate.
Well, you can shield. You can shield the magnet from certain. Like you can make the magnet, instead of being magnetic in all the directions, you can apply an electrical charge, like with a battery, and make it so that only one side of the magnet is doing the work. So, have you ever seen that? Where they it's like a little metal foil pack, and he puts like a 9-volt battery or a AAA battery inside there, wires something up, and then puts this neodymium magnet, and then runs another magnet behind this being shielded, and like the electricity is making it so there is no magnetism in the front, and then in the front where it's not magnetized, it snaps together. So I think like something to do with having the proper angle on all of those, like for example, in a circular device, with what you said earlier about like this, like a timing, like turning that electricity on and off at right times, like to get it to go through the gate, to get it to push through that negative area where they're repelling each other. I think that seems like it's very doable.
Pulsing.
Yeah, there you go.
Yeah, asymmetrical design, I think, usually works with those. Like, I think that's what's in common usually with magnet motors. They're not. It's not a symmetric array. Maybe maybe there is some there, man. I have personally not experimented. I'm not a fan of magnetism. I'm a fan of the other half of the electromagnetic wave, the electric bit is where the dielectric is where the true ether lies. You know, this is where the magic is.
It's
The other half of electricity.
Yeah.
Correct. The longitudinal waves. Yeah.
Exactly,
bro. Right on.
Then
That is the key.
okay.
Apparently, that is the key. Not magnetics. You know what I mean? Tesla very clearly in his writings, he had to shun out the magnetism out of his circuit, right? He had a magnetically quenched spark gap where only the electric field, like the electric tension or the longitudinal waves would go across that gap, and all the magnetism, according to him, would be shunned. So that's the key, is get rid of that shit. It's parasitic, apparently. When we're talking about these advanced systems, we want to no magnetism. We're dealing with electric only transmission, which is we don't have the curriculum to work with it. We just have Tesla's shit, essentially.
Kind of. I mean, like James Clerk Maxwell, he did all his equations in an old mathematics or arithmetic called quaternions, which is basically a four-dimensional representation of 3D, right? And
you've heard of Thomas Brown?
Definitely.
He's the editor-in-chief of forgot his magazine, Borderland Science. He's got okay, man. Yeah, quaternion. I was like, yeah, sorry. Preach on, brother. Preach on.
Oh, well, anyway, it took Oliver Heaviside to come along and basically translate the best he could to linear algebraic equations so we could practically utilize this in the field. Of course, it took Steinmetz to, work out the alternating currents phenomena. But anyway, the translation from Maxwell's to Oliver Heaviside's also, admittedly by Heaviside, he saw a couple things need to be tweaked, for the translation to work, and he felt like, that James Clerk Maxwell would agree, as far as the translation goes. But anyway, that was part of his foreword, I believe, in the presentation as he presented it. But yeah, dude, I'm like old school. I'm familiar with more than one theory, technique, and practical application. Half of which seems to be left out of modern electrical and teachings and whatnot. Which that's cool. It's just incomplete. That's the main thing. From what was taught before, a lot of stuff has been automated, and you have programs to do all your load calculations, so you don't have to account for the different phenomena that we still have yet to grasp what's actually occurring.
They got to dumb us down in school.
Of course. I mean, like, if you finished all your work and you aced your class and you're daydreaming, right? What do you get? Disciplined. Don't use your imagination. Don't use your creativity. No. Conform. Stay on task. Even if there's nothing for you to do. Right? Fucking ridiculous.
Have you, Levelist, have you seen the cosmic induction generator built by Dollard, the old one in the 80s?
Cosmic induction generator? I have not. All that stuff's over my head, by the way. I wasn't big science guy in school. And those guys in Thompson, and those books are like borderline minor IQ, in my opinion.
Audio, bro. Audio. Reset it.
Your mic, bro. What the hell? Whoa. Oh, static demon or something you got over there. You got your Tesla disruptive discharge going on.
We good?
Oh yeah.
There we go. Oh my god. So what were you saying?
I was saying that those books are like that's above my pay grade. I think that all those Heaviside and Thompson books, dude, those things are like 150 IQ, at least like a 140 IQ to understand those books.
Not necessarily. No. Just an excellent student to be a good teacher to help you recognize with illustration and practical application instead of just a mountain of data to attempt to memorize. It's just totally.
I was having to like stop almost every other sentence. I had to stop to go look up these words and like the context that they're using these words in, you know, because I was attempting to not learn electrical theory through the modern day lens. I wanted to learn it from the time period this way. Like, and I was just like, dude, this is going to take forever to get through this shit.
No. There's people that can help you. Well, hell, I'm right here. I can share my perspective and then others' perspectives. That's mainly what I want to share is others' perspectives. That help me come to my ability to recognize what I now recognize. Hindsight. After 25 years as a HVAC refrigeration technician and test and balance engineer and electronic technician, et cetera, et cetera, et cetera. LP gas master qualifier. There's a lot of knowledge that you have to at least memorize for a short period and repeat the dogma for maintaining licenses and obtaining permits, licenses and qualifications. There's a lot going on, and I watched everything change. The ability to evaluate for ourselves is pretty much a lost art now.
Yeah, I would also argue that because of the invention of the solar panel and the price at which you're able to acquire them, that the main purpose of going back in time and learning that electricity through their lens would be to create another Wardenclyffe. Because I don't want to downplay all the rest of his inventions, but that's the one that we're actually needing the most, like pulling it straight out of the ether. Right? So unless we're going to go back and actually do that, I'm like, all right, solar panels is just a quick, easy way to get the electricity I'm looking for.
That's why I asked you about the cosmic induction generator. Have you seen that?
Let
Dollar
me look it up.
in the 80s.
Can I find it on YouTube or no?
You'll find still photos from 87 or something like that by Eric Dollard. You'll see a light bulb on a PVC pipe or something like that, or a wooden dowel between two Tesla coils, real Tesla coils. And this is where the discussion is right here.
Well,
what in the world is going on?
Like with the Fendercraft generator, most people don't recognize that the charge is being carried across the insulator. Which, yeah, this guy right here, he's pretty sharp too, no doubt. Wow. Eric Dollard.
Oh, Eric P. Dollard is, I believe, the only man, and he's still alive, to replicate all of Tesla's patents on video. He didn't play any games.
Oh, he did more than that. He accidentally.
Oh, the cosmic.
Across. Yeah, exactly.
Yeah, go ahead.
Know what I mean? No, you already know.
Cosmic induction generator. Between that field, this is where it's like, okay, I need to build that, and I need to get there. Once you put that light bulb there, and you get these weird anomalies, okay, you got the right field of stuff. Now it's like, okay, I'm going to take the wire off that coil and put it in my electrolysis cell. See what happens. Maybe nothing. Maybe maybe that's the key. This other electricity. You need a method of verification that you've reached it. Which this is a really good one. And what is going on there is no idea.
Is this brand new? Does 2021 sound right, or is he just reposting an old video?
This is this is the remake. So there's Gremlins with this device, and that one that he built in the 80s for some reason, whatever it was, right? It just worked. All right. He talk about this. He attempted to build this multiple times, and they're just very finicky, extremely finicky. Tesla tuned them by I believe weighing the coils to the mass of the coils. So anyways, that one in the 80s, look up cosmic induction generator, and it's the older one. Scroll through the photos, the images on Google, and you'll see a light bulb with like cosmos inside of it. Weird plasma anomalies.
Do you trust Aaron Murakami?
Hell no, he's CIA 100%. Fuck that guy. He's the one that shut down the fuck dude. In 2012, they found Dollard in the desert. They GoFundMe, raised 30 grand for him. This is where Ken Wheeler and myself start learning about what Ken Wheeler knows from this right here, this incident when they grabbed Dollard out of the desert, crowdfunded, got him a nice laboratory, started gathering equipment, and then Aaron Murakami hops in, and everything goes to shit. Right when they were about to build the cosmic induction generator again, and then Aaron Murakami, the lab gets confiscated, and everything goes dark. He starts reselling the old Dollard material every year for money, and we get nothing. And then some guy built this, and it doesn't work. Like the one that you'll see in 2021, this is not what the old one was doing. But it does interesting. It has interesting anomalies, but it's not like the old one.
So that's
yeah,
almost
dude,
the same exact story. I'm following this guy. Like I said, when I was going through my Tesla turbine rabbit hole, there's a young kid. His name was Jeremiah Ferwerda. He is like 5 or 6 years deep into his Tesla, his Tesla research. He has a partner, an older white guy. They're getting really close to putting out a product. Essentially, this partner, the old white guy, dies. I don't know. He didn't look like he was all that sick in the last video that I saw. His last interview. And Murakami swoops him up, takes him up there to fucking where's he in Spokane, something like that. Puts all of the shit behind a paywall.
Paywall, yep.
And we're a year, and I've been waiting a year and a half for the latest updates. It's every fucking month he puts out like one video, and he's like, "We're just waiting on this stuff, guys."
Buddy, I bought the fucking shit material from Murakami after he scooped up $1. Okay, I actually paid for a fucking book, and it was the same old stuff that he gave us for free. When his books from the 80s,
Right.
he just puts it together every year and fucking packages and sells it again.
That that video I sent you earlier on the cryophorus system, where they sucked, they put the two different systems under a vacuum. One was heated, one was cooled, and it was running indefinitely as long as you keep them hot and cold. So that's his basis. That's where I found that is Jeremiah Ferwerda, and he's running a Tesla turbine in between those two bottles being connected on a bigger scale. He's using like a big old tank, and it looked like it was fucking working. He was getting quite a bit of electricity, and it was, I'm not saying it was running perpetually, but he had one of the tanks was outside in the cold. I forget where he was at. He was someplace cold, and he was just heating the other side up with propane tank, but you could easily replace that with the sun or solar panels and the electric wire we were talking about. And he was getting like 5,000 watts worth of electricity out of that Tesla turbine, and it was running at like fucking like 50, 60,000 RPM or something like that.
Yeah, they're high RPM machines.
So yeah, he's gone. That information's lost to the ether.
Yep. So yeah, Murakami scooped him up. It's goodbye, bro.
I found an interview with Murakami. He was interviewing a Mason. They were like talking about Freemasonry, and I was like, all right, that makes a lot of sense.
Dude, he owns energetic forums and all the other free energy forums. It's kind of sad. He's the man, dude. He's their guy to keep the shit just hidden. Bro, it was right there. They were about to put this shit together, and bro, it goes down. And guess what? The website, all these books I have, the gigabytes, this is exactly where I got it from. There was another website that they made and uploaded all these books. They're all out of print. Most of them are out of print. And so they're out of copyright. Anyways, Mr. Murakami goes in there and gets it shut down too, bro. Even there's two websites, right? One that had all these, like, had the videos of Dollard was put out by the guy that found him in the desert and all that shit. And then they started the other websites, kind of a safe for all these books, right? And yeah, bro, both got taken down essentially. Done.
You've heard of the
website is still up.
The Invention Secrecy Act. You heard of that? Have you heard of the Invention Secrecy Act?
Yeah, national. Yeah, under National Secrecy Act and shit, or 1951 or some shit like that. 40 set. Yeah. Solar panels 20% efficiency only.
And what is their theoretical? What is it's like 45%, right? Is what they should be. What the theoretical limits to solar?
From the 70s, they were at more than 20%. So 22% from the 70s. It's like, bro, we should be at 50%. Cool, 45%. I'll take that.
You just buy double the amount now.
Yeah, then Dollard and his analog computer stuff. This is where things get wild, and they're so awesome and interesting. I'm gonna get some analog computers. Where he said you can get the same effects that you can get out of a Tesla coil with these analog computers. It's very interesting.
All right, gents. I'm gonna call it a night. Peace out, y'all.
The first one.